Another way as well, wherein you can download the SPSS, you have to just create an ID with IBM. You will be getting a 14 or 15 days free trial of SPSS. Sure, ma'am, Jyoti ma'am, I will share this module. Software says it has expired. Okay, so we need to get in touch with the IT team if it says that. I believe your free trial version has been expired. That's why you're getting this pop-up. Alright, so this was all about the base module itself. Then we have an add-on module known as an advanced statistics. So basically this add-on module provides you the procedures that offers advanced statistical modeling options to analyze your data that has unique characteristics. Example would be a simple example would be a describing a relationship between a dependent and a set of independent variables, which helps you to gain deeper insights to help a real world problem in disciplines such as manufacturing, pharmaceutical, and market research, and many more. Yes, so you can download. You will be getting a full version for free for just as in a 14 or 15-day trial. You can just check it out on IBM India. Yes, it is a recorded session as well. So thank you. So where were we regarding the advanced statistic add-on module? So these are the other key features which comes with the advanced statistics add-on module. Request you to please go through it so you will have a brief idea about it. Example, Bayesian statistics, general linear mixed model, general linear model, variance component analysis, and many more. These are the other key features which comes with the advanced statistic add-on module. These are the other ones as well. Then we have an add-on module known as in bootstrapping. So as bootstrapping, it is nothing but a resampling technique which is used to increase the accuracy of your analysis. In machine learning, this is basically used to improve the accuracy of your analysis as well. So this, you can say that this is a method also consisting in repeatedly drawing samples from your data sets and calculating statistics and then perform matrix on each of those samples. As I told you, in machine learning, this is something used for the performance of model. And one thing important about bootstrapping that bootstrapping, you cannot bootstrap all of the analysis in SPSS. So there are only certain analysis which you can bootstrap and improve the accuracy. The techniques which you can bootstrap are listed below over here as well. Request you to please go through it so you will have an idea about this as well. Okay, so this was all about the bootstrapping. Then we have an add-on module known as direct marketing. So basically this module was prepared specifically for marketing purpose. Okay, so you can say that with the help of this add-on module, you can conduct advanced analysis on your customers or your contacts. So choosing from recency, frequency, and monetary analysis, which is known as an RFM analysis, cluster analysis, postal code analysis, which eventually helps you in understanding your customer in depth, improving campaigns, and maximize your ROI of marketing budget. And this was about the direct marketing. The other key features which comes with it are listed below over here. Please take out some time and go through it. Then we have an add-on module known as in conjoint. This is also a module which was specifically designed for marketing purpose. So you can say that with the help of conjoint analysis, you can understand the preference of your customer. It also helps you to uncover information about how a customer compares the product and market and measures the individual product attributes on consumer behavior. So basically with this information, you can design, price, and market your product or services tailored to your customer needs. So this will be the main feature of conjoint analysis, and the other key techniques which comes with it are listed below over here as well. Request you to please go through it. So it's all about the conjoint module. Then we have an add-on module known as an exact test. So this add-on module gives you the capabilities to obtain accurate results when you have small number of data sets. You can say that when assumption of your analysis might not be met by your data. So with the help of this module, you can work on that small data set. This add-on module provides you two additional methods to do so. One is exact Fisher test. One is Monte Carlo's method. Request you to go through the other key features as well. So I see one question from Chetan VG. Please explain from the perspective of how this can be used for research and studies. Sir, what are you addressing over here? Which module? Will you please say that? For PhD. Okay, which module are you talking about? Or are you talking about the overall software? Overall. So overall, sir, that I will take really a lot of time to explain you in terms of PhD, or in a simple manner, I can say that in terms of data analysis. Okay. So basically, sir, SPSS provides you all files or various type of data set. Example, text data, CSV data, XLX, and so on. So you can import all of this type of data sets in SPSS and start work on that. I'll give you an example of that as well in the coming session. Then you can perform certain analysis. You can prepare your data set for your analysis. You can trim, you can merge, you can identify duplicate. I'll give you you can come, you can do all of the analysis process without going possible for standard statistical method. So this will be about the category add-on module, and the other key features which comes with this add-on modules are listed below over here as well. Example, correspondence analysis, multiple correspondence analysis, categorical regression, and so on. The key features are listed below over here as well. Request you to please go through it. Then we have an add-on module known as a neural network. So as you know that neural network, it is a predictive technique which offers nonlinear data modeling procedures, which enables you to discover more complex relationship in your data. So you can say that it is an AI technique, an artificial intelligence technique. With some example would be multi-layer perception, radial basis function, and so on. I saw one more question. Let me just see what it was. Sir, just a minute, sir. Sir, it needs to be objective data based on numbers only. Can we use it for subjective replies as well? Yes, you can recode your variables into a categorical regression as per your need. Sure, sir. Suresh Raj, I will share the manual as well. So you can say this is a module specification. With the help of this, you can have a brief idea about it, what all techniques or key features you have. You can utilize it. Okay, so this was all about the neural network. Then we have an add-on module known as in custom table. So basically this add-on module helps you to customize or summarize the SPSS statistics output in your need manner. As per your need, you can customize or summarize your output in SPSS. It does offer some advanced features that allows you to build tables which can be easily understood by your people or your team, and as everyone know that it has a very easy to use graphical user interface and formatting controls. And the other key features which do come with the custom table add-on modules are listed below over here as well. Request you to please go through it. Then we have an add-on module known as in data preparation. So you can say that this add-on module has some advanced techniques that help you to streamline or make your data preparation stage easy. You can say that it is also a tool which helps you to benefit in delivering fast and accurate results for your analysis. You can validate your data, you can make your use the automatic data preparation mode, you can use optimal billing and so on. These are the other key features of data preparation add-on module, which basically helps you to save your time for your analysis. Request you to please go through it with the other key features. Then we have an add-on module known as in decision trees. So this add-on module helps you to identify groups, discover relationship, predict future events. Then it also helps you to present categorical result and explain analysis more clearly to your non-technical audience. You can create models for segmentation, stratification, prediction, data reduction, and many more. The other key features which comes with this add-on modules are listed below over here as well. Okay, so this was all about the decision tree. Then we have an add-on module known as in regression. As you know that it is a family of classical predictive technique. It do contain a wide range of non-linear regression module that augments the linear regression functionality from the SPSS base module itself. Some of the example for regression would be multinomial logistic regression, binary logistic regression, nonlinear regression, and so on. These are all the advanced regression techniques which do comes with this add-on module known as in regression. Request you to please go through it so you will have a brief idea about that. Then we have a add-on module known as in forecasting. So as you know that it is a time series module. For a simple example for time series, it is nothing but a set of or an observation obtained by measuring a single variable over time. You can say that. And as you know, the time series forecasting is the use for model to predict future events known on based past events. Okay, and the other key features which comes with the forecasting add-on modules are listed below over here as well, as in time series module and so on. There are so many features in the forecasting add-on module as well. Request you to please go through so you'll have idea about it as well. Then we have a last module known as in complex samples. So you can say that this add-on module was designed to help you reach the correct point estimates, or you can say predict numerical outcomes and categorical outcome as well from non-simple random sampling. It improves the accuracy of your results, accelerate your analysis, boost efficiency, manage complex survey data. These all things you can do with this complex sample add-on module. The other key features which comes with it are listed below over here. Request you, yes, you can. You can both use quantitative and qualitative data with no issues. So this was all about the complex samples. And we also have a add-on module known as in missing values. So you can say that this is a very helpful module which helps you to manage missing values in your data set, draw some valid conclusion from it. Then it also helps you to build models that specifically account for missing data and remove some hidden bias if you have in your data set. You can create models specifically for missing values to analyze your data, how many or how often you have missing values in your data set. You can create the trends of that. You can see the trends, how the missing values trend follows for it, and so on. The other key features which do comes with the add-on, this add-on modules are listed below here as well. Request you to please go through it. These are all the other techniques, multiple imputation and so on, which comes with this add-on module. Then we have a separate standalone software which is known as in Amos. Currently we won't go in detail about this, but a small overview. As IBM SPSS Amos, this is a structural equation modeling which is specifically used for research and all. I won't go into details as we have not scheduled this for. So This was all about the IBM SPSS, the modules it comes with, the key techniques you get in each and every module, and how do you get started with IBM SPSS. Okay, so let me take you through the interface now. How does the SPSS interface look like? I hope my screen is visible to everyone. So this is how the
Yes,
interface of
yes.
SPSS. Thank you for the confirmation. So this is how the interface of SPSS look like. Okay, it is basically a small window like an Excel itself. You have rows and columns. Variable views names the column name over here. SPSS offers you two views. First of all, one is data view, which is this view, wherein you can see your data, feed your raw data directly. Then we do have a variable view. This is where you're going to define your variable before any analysis. This is a very important step. Once you import any file or any data set into SPSS, it is very important for you to define your variables, because this is how it's going to result in your analysis, how you define your variables. Okay, I'm going to give you an example for that as well. As you know that it is a graphical user interface software, which is really easy drag and drop menu kind of a thing. We do have certain main features in SPSS. As you can see, these are all the menus in SPSS: file, edit, view, data, transform, analyze, graph, and so on. File, data, transform, analyze, and graph. Okay, file, data, transform, analyze, and graph. This will be the five most frequent options you will be coming across when you are using the SPSS. Trust me, it is not easy for you to learn this SPSS in one day. You will require minimum 1 month of training on this, but once you get hang of this, you're gonna save a lot of time in your future for your analysis or your research. Okay, so request you to please do practice a small little time on SPSS. You will get hang on of it, and trust me, you will be master soon as the time goes. So file, data, transform, analyze, and graph. This will be the most often one which you will be coming across for your analysis. File will help you to import and export data set from SPSS in SPSS. If you want to see what all types of file you can import in SPSS, you can just come to over here, import data. Over here, you will see the list of files you can import into SPSS: Excel, CSV, text, SAS, and so on. You can also connect this SPSS with your database as well if you are a programming geek. Or these are the other options. You can export your data set from SPSS into these all options. Request you to please go through it. So this is a small information about file menu. Then with the help of data and transform menu, these two menu will help you to prepare your data set for your analysis. Okay, so do remember, data and transform menu, these two options will help you to manage your data or prepare your data set for your analysis. You can say this two menu will help you in data wrangling process as well. As per the options itself, you can see you can define some variable properties. You can validate your data with, if you have data preparation, then only you will be getting this option. Or you can do check from your end. You can identify duplicate cases, unusual cases. You can sort cases, sort variables. You can merge files as per your cases or as per your variables. You can restructure. You can split into files. You can create an orthogonal design as well. You can split file, then you can provide some if condition if you want to. I'll give you some example about this as well. So this is all about data and transform menu, which will basically help you to prepare your data set for your analysis. Okay, so as per this menu, you can compute variables, means you can create new variables. Okay, and so on. You can record some way into same variables, or you can record into different variables. You can create dummy variables. You can create some binning. You can prepare data set. This is also a data preparation technique. If you have opted in for, you'll be getting this option only. So currently I have the complete version of software. If anyone has any question, that's why you'll be getting to see a lot of options. Then you can create time series module. You can replace missing values. You can create random gen numbers from this menus itself, data and transform. So whatever techniques you require to transform your data or prepare your data set for your analysis, you'll be getting under this two options only, data and transform menus. Okay. And one important thing about SPSS, as SPSS offers multiple ways for you to handle missing values in your data set. A simple example would be here. You can replace certain missing values if you have any. Then we have an analyze menu. So whatever analysis you can perform in SPSS, it will be shown under this tab only, the analyze tab. Okay, so whatever module you have opted in for or whatever analysis you can do in your system with SPSS will be shown under this tab only, the analyze. So power analysis and meta-analysis are the new features and so on. So these are all the list of analysis you can do in SPSS and so on. Then we have another menu known as in graph, which can be used to create certain graphs for your visualization for your analysis. And in case if you have a specific type of a graph in your mind, you can just use this shortcut legacy dialog box with a specific data visualization type. Then we have an utilities and extension. I'll explain you utilities and extension as well. So first I'll go with the extension. Then we have a extension hub in SPSS as well. This extension hub is free first of all. There are more than 130 extensions which are compatible with this all programming language. If you are a programming geek, you can explore this extension hub as well. These are all the categories on the left hand side you get as in checkbox as per your needs. And these are all the extensions you will be seeing over here. A simple extension example would be text analysis as well. These all extensions are first of all free and created by some person who've been using SPSS from the different countries or a different part of the globe. Okay, so each and every extension will require some prerequisite for you to get started or get this extension in your system and work on that. You have to just make sure the prerequisites are fulfilled and just get this extension as per your need. So request you to please do explore this as well. So there is an helpful fact as in portal community as well who works on this in different kind of extension. Request you to please explore that as well. So this was all about the extension menu and window and help. Okay, so now let me go ahead. Till now, does anyone have any question? So I'll address them and start with the next topic. Can you explain data subcategory again? I'm so sorry, sir. Ma'am, I guess I lost it. Data subcategory. Will you please explain that again? I'm not sure exactly what you're talking about. Okay. Extensions are available in all versions. Yes. Ms. Kavita, extension are available in all versions. But in the latest version, there will be some enhancement as in some more prerequisites you will require as in the 24th or some earlier, the last version, there was some problems as well with, some extensions. So in the latest version, it has been fixed those bugs. You can say that. All right. So does anyone have any question? Can you explain the utilities tab again? Was that the question from Nirud? Yes. So, okay. So utilities are nothing but what all add-on things you add into your SPSS or extensions will be shown under this tab only. Okay. So Miss Kavita is asking, I'm using the 21st version. It is not visible. So ma'am, maybe this would be an enhancement as well, that after a certain version, you cannot use certain techniques. You can say this. So in the utilities tab, you will be seeing all of the other add-on extensions you have added into your SPSS or your current software in your system. This is where you will be seeing all the add-on things. So this is all about the utilities. So now let me give you an example how you can import a file into SPSS. You are talking about data utilities tab. Mama, I guess you are asking about this tab, right? Utilities. Yes, that's what I said. Whatever extension you get or whatever extra things you will be doing other than an analysis in SPSS will be shown under this tab itself. So recently I came across some person from Australia has developed macros as well. So I tried that as well. So request you to please explore that as well from your end. There are many things you can do in SPSS. All right, so let me give you now example how you can import a data set. How you do that? You go to file, open and data. After going into data, you have to just navigate through the path wherein you have saved your data set. It could be the desktop as well. So currently I am in the path wherein the .sav extension files. So first of all, .sav, do not get confused. This is the sample data set which do comes with IBM SPSS itself. So this is the path. If you want to know where it has been stored, you have to go to local disk, program files, IBM, SPSS statistics, sample and English. English is the base folder wherein you will be getting all of the sample data set stored. Okay, so for this demonstration, we will be using only demo data sets which comes with SPSS itself. So one more important thing, in case if you are using SPSS and you are facing some issues, you want to know what are types of file you can import into SPSS. This is the one way as well to check what are type of files you can import in SPSS with this drag down file types. So in case if you forget how what all types of file you can import in SPSS, you can just come across this menu and use this. All right. So let me just open a demo data set for you. So I'm going to use demo.sav. You search the file name and click open. So this is how the data set will look like in SPSS. These are all the columns. These are all the columns. We have age, marital status, address, income category, car category, and so on. Then this is where you can directly feed your data or make any changes. You can do any changes over here itself, the data view. And this is the variable view wherein you have to, before any analysis or once after you import any type of data set in SPSS, first you have to come through this variable view and define your variables properly. Then only you will be getting some accurate results for your analysis and some relevant results. Okay. Now I'm going to give you an example of each of those columns, how they play an important role in while defining your variables. Okay, first thing first, we have a column known as a name. So name column is used to give a name for your variable. Example, as you know, that we have age variable, marital status, and so on. These are all the name of the variable. This is how you can give a name to your variable with the name column. So before giving name to your variable, you have to make sure that you cannot, okay, so you cannot start with any numbers or any special case characters, as this is a case sensitive. So when you are naming your variable, you have to make sure you name it in a plain and a simple English format. Okay, in a small words as well. This has some restriction as well. You cannot name it for the certain characters. So you can just see that we have named all the variables in a short and a simple manner. Now, in case if you are finding it difficult to name your variables, you can use this label column as well, wherein you can give a proper label for your variable. Example age, we have mentioned it as an age in US, marital status, address, years at current address. So this is how you can use the label column to give a small description about the variable name. Okay, you have to make sure you do not name your variables with a special case characters or any special case numbers, or it cannot start with the capital letters as well. That's what you have to make sure while defining the name or giving name for your variable. So this was all about the name and the label column. Then we have a type column. So this is helpful when you have to define the type of variable you need for your analysis. A simple example would be, if you want to define the type of variable, you have to just click through this three dots over here, a small. If you click through here, you will be getting this dialog box wherein you can define what type of variable you need for your analysis. These are all the type of variable you can define: comma, numeric, dot, scientific notation, and so on. Numeric, date, and string. This will be the most common you will be coming across in your analysis or your research. Okay, so make sure you define the type of variable properly. How do you define it? By clicking on these three dots, you can define the type of variable you need for your analysis. Okay, so this was all about the type. Then we have with and decimals. So this is not much that useful, but in terms of research and clinical studies, this is useful. How it is useful, I'll give you an example for that. So in case if you want to restrict, okay, restrict a certain characters in your variable. Okay, so over here, as in you can see age, we have restricted the width as in 4. So in case if you want to restrict the width of your variables, now if you see, I can type 7, 8 and so on as well in this. But in case if you go ahead and restrict the width of your variable over here, you won't be able to put the fifth or sixth character in this variable. Okay, so that's how it is useful to define a specific width for your variable in the input section. Same goes for the decimal section. In case if you want to increase or decrease the width, you can just toggle through the small arrows up and down. So this is how you can increase the width of your variable or increase the width of your decimal points as well. This is how you can do it. All right. So this was all about width and decimal. We have gone to label as well. Then we have column known as in values. So this is useful when you have categorical type of a variable in your data set. A simple example would be this. As you can see, we have a categorical variable marital status. How you define that? You have to just click to this small three dots. Okay. So as you see that marital status is our categorical variable, wherein we have defined 0 as in non-married and 1 for married. So this is how value column is useful. In case if you want to add third variable, you have to just click to and I add the third categories as well as per our need and just click add. Okay. Same goes for if you want to remove, you can use this option. So this is how value column is useful when you have categorical type of a data. I can give you some more example as well. As in for income categories, we have defined one for people who have income less than $25,000 and so on. Right, so this was all about the value column. Then we have a column known as a missing column. As I told you, that SPSS offers you multiple ways for you to handle missing values in your data set or in your analysis. This is one of those ways wherein you can see, I can give you an example. You have to just click through this three dots. So over here, what we have done in our variable name internet, we have replaced the missing values if we had any in our data set with a discrete values 8 and 9. I can give a single value as in 8 as well, but just as this is a demo data set, we have just replaced those missing values as in the missing columns with 8 and 9. Okay, give you an example over here. Our variable was internet, right? So this was the variable internet. As you can see over here, there was no values, so it has been automatically replaced by 8. So in case anyone has any question why 8, how will they define the SPSS will define by an 8 by a 9? It is just a random number we have given. So there is no logic behind this. The SPSS will randomly give the missing columns this values as per our need. You can give a range as well or no missing values is there. You have to just click over here. So this is how missing value column is useful when you have missing columns in your data set. Then we have a column known as in column and alignment, which is not that much useful. It is just for the view if you want to define. Then we have the most important column in SPSS known as in measure. Okay, so this is very important. SPSS offers three types of measures: scale, ordinal, and nominal. Scale are for all of those variables which are continuous or which are numeric in type of variable. That's what I'm talking about. For every numeric variable, you can select scale. Then we have an ordinal and nominal. Nominal are for those variables which can be categorized. Example, marital status or income category. That's categorical variable. So this is nominal, you can define for that. and ordinal for those categorical variable which can be rank ordered. Okay, so there is a small difference between nominal and ordinal. Nominal is for basically all categorical variables, and ordinal is for all those variables which are categorical and can be rank ordered. Example, a simple example would be here this income category. We can do some categories, perform, make some rank order under this variable. That's why we have selected ordinal. Same as it goes for your employment category, we can rank it order. That's why we have selected ordinal. So you have to make sure you properly define the measurement level for your variables. This is very important. The last column defines the measurement level of your variables. Then we have a last column known as in role, which is not that much useful. So in case if you import any data set into SPSS, this all columns will be automatically populated. It's your duty to come here and check each and everything is defined properly. So then you can go ahead with the analysis. And about the role column is nothing but you can specifically define a certain role for your variables. These are all the options SPSS offers you: import, target, both, none, and participant spread. So you can specifically define a type of role for your variables while coming here. So this is how you can define variables in SPSS, and it is very important because this is the first step once you get import any file into SPSS. All right. So till now, anyone has any question, please ask. I'll take a pause for 1 minute in case anyone has any question. Any doubts?
Hello.
Hello. Yes, ma'am.
Yes, good morning. Sir, I want to ask, why did you put scale measure on marital status? It's a nominal, na? You have given categories to it.
No, ma'am. Was marital status? Oh, ma'am. While giving an example, I just did that. So this is automatically populated first of all.
Yes.
That's what I was giving example. So sorry. Thank you for pointing it. That's a good question.
Okay.
So I guess saying a question, internet missing was a bit confusing.
Sir, in the role, why all of them are as input?
This is automatically populated by SPSS. This all, first of all, we have the do define certain variable properties type, but in case if you import a new data set, this fields will be automatically populated. It is your first job to come over here and define your variables properly. Means as per your need.
Yeah,
Okay.
but then there are various options given in the role. So which, how do we identify that?
So it depends upon, ma'am, the studies, the field of studies as per your need. So in case if you want to perform a linear regression or if you want to check the relation between certain variables, we can directly come into this role table or role view, variable view, and define the type of role we want for our variable to perform in our analysis. So we can define it over here as well. If you want certain variables to perform both input and target role, you can define it here as well. So that's how it is useful. Internet missing was a bit confusing. So it is confusing if you think so. So it is nothing confusing. I'll try to explain you in a simple word. So we have a variable known as an internet, wherein we think that we do have certain missing values. So what we have done, we have come to the variable view, click on three dot, and we have just replaced all the rows or all the cells which have missing values with this discrete values. Okay, so this is provided by us. I can remove this and I can either give 8 as well. Okay, I can also give 2 as well, or I can give 3 as well as per my need. So it depends upon your studies or your type of questions or you are trying to solve with your data set.
It can be the highest and the lowest number in those.
Yes, it can be, sir. It can be as per your need. This is all as per your requirements. You can do.
And one more question, sir. Variable type should be defined by us, or
Each
is
and everything, sir. Sorry to interrupt. Yes, please go on.
No, that's the question.
Okay.
Variable. Yeah.
So yes, variable type. As I told you, whenever you import any data set into SPSS, these all fields will be automatically populated. This is how SPSS is designed. Once you import any file into SPSS, it's your first prime duty. You have to come over here and define the type of variable you need for your analysis or your research. So as I can see, each and every research or any question or any analysis, you will require different type of variable in your research. Okay. So this is how you have to first come here and define as per your need. Okay. You can directly go with the automatically populated options as per your need, but you have to define it.
Sir,
So I see.
apart from internet, where we use that missing variable, sir?
I am so sorry, sir.
Sir, apart from internet, where we use the missing variable?
Okay, so missing values may you're saying that my internet was lagging, right?
Yes, sir, exactly.
Okay, so I'll explain missing values once again. So missing values is basically used for if you have any missing values in your data set, you can come into variable view, missing columns, click on this three
Okay,
dot
sir.
and replace if you have any missing values with any discrete values as per your needs, as per your requirements, or you can also give a range as well, or any discrete value. So this has to be
Okay,
done as per your need, okay?
okay, sir. Okay, thank you.
So I see a question from Neha ma'am that sir, could you please report how to
This is
import
Deepak
data?
Shinde.
I'm so
So
sorry.
this is Deepak Shinde. I just wanted to know these variable views are programmable, so whether I can add rows with my own idea like status. If I wanted to add status, if I wanted to add pass, fail, can I add additional rows in other than this name type with decimals, label, value,
Yes.
these things?
Good question, sir. Good question. Yes, you can. You can directly if you, that's what you're saying, right? If you want to add new rows for your variables. So you can just come over here, create a new column, grade, define the type you need for that. I want a grade to be numeric. Define the type of width you want required with the decimal. You can put label for that grade for students over here like this way. Then if you want to provide, if you want this to be your categorical variable, you have to just come over here, select the values you want to get the grade for, select a label for that, add it as per your needs. Then if you think that you have a missing values, you come over here and place those missing values as per your, you can add as per your requirement, many rows as per your need. So then I see a question like from Niyam that will you please report the import part. Yes, ma'am. How you import any file in SPSS? You come to file, open data. After you click data, you will be getting this window wherein you have to navigate through the path wherein you have stored your data set or saved your file at. It can be a desktop and so on. So right now we are in the local disk program files, IBM, SPSS. Sorry, this is the Amos. IBM SPSS statistics, then samples and English. If you want to work on the sample dataset, this is where the path wherein you can find this. I hope ma'am I have answered this question. Variable type should be defined by us. Yes, Anirudh, so you have to define by yourself because it's your question you're trying. Then I see clinical psychology. Can you please explain the variable types? Yes, I can explain you what is variable types. Variable type is nothing but these are all the types of variables you can define into SPSS. These are all the different types. Can be a numeric or a comma or a dot, scientific notation, date type, dollar, custom currency as per your need, or string or restricted numeric. So these are all the types of variable SPSS offers you. You will be most often you'll be coming across numeric, date, and string. This will be the most often one. Yes.
How do we define string?
How do you define string?
I mean, like, what is it?
What it is? Okay, so basically string is useful in survey type of data. Okay, so you can say that if I want a string type of a data, just a minute. Give you an example for that as well. Okay, so over here you can see we have a variable name as in gender, wherein we think that it is a string variable because gender can only be male and female, right? So we have come over here, it's a gender. We have also defined that it is a categorical variable, it is a string type, it cannot be numbers, but yes, we can replace it with numbers as well. Over here we have given a labels as well, F for female, M for male. That's how string variable can be used. And in case if you want to define it 1 as in female, 0 as in male, you can do that as well as per your need. It totally depends upon your need and that question you are trying to solve. Any other question?
Sir, this is Deepak again. This is regarding
Yes.
variable view.
Mhm.
As you add the new column in variable view, I just wanted to know whether I can add additional row next to what is this role?
This is not
No,
possible, sir. This is
next to
no, sir. This is the predefined one. You cannot toggle with these things. But I'll put through a suggestion in IBM. I guess they will come across some solution.
wanted to like status in progress or paid or anything like that. So that's what I'm asking. Maybe any other column. That's what. Thank you very much.
Sure, sir. All right, so this was all about it. Then simple example how you can run a frequency or a summary statistics in SPSS. As I told you, whatever analysis or whatever descriptive you want, you will be getting under the analyze tab. So to get the summary, you go to descriptives. In this descriptive menu, you will be getting all of the frequency, descriptive, population descriptive, explore menu, then cross tab. So one important thing about SPSS, in order for you to perform a chi-square test, you will be getting chi-square two places, as in this is the one way when you can get the chi-square test through this cross tab menu, and one is non-parametric test. Once you opt in for the exact test add-on module, this is where you get the other option for chi-square test, which I think it is important to let you know. So I did. So in order to run any summarize of frequency, you come to descriptive. First of all, you come to analyze, you go to descriptive, then let's just go for a frequency first. As everyone know that frequencies can be run only for categorical type of a data. So we're gonna select some categorical type of a data over here. You can either drag and drop or you can select the variable, use this arrow like this way. And so with every dialog box in SPSS, you'll be getting this kind of an option as in a side option. I request everyone to do explore this kind of a small menus. You never know that in just one click, you can get so many measures at once. Simple example would be if we come, if we have, as you see, we have gone to the frequency, we go to statistics and click over here. You can see that we are getting so many measure values. Just a minute. Okay. All right. So as we clicked over here, statistics, we got this dialog box. So you can see that with this dialog box, we can get the central tendency as in mean, median, mode at one click only. We can get the dispersion of our variable in one click only. All right, you can get skewness, kurtosis as per one click only. We can get the quantiles, we can get the mean, median. This is just randomly I'm selecting, okay? You can just explore this from your end, hit continue, then just a minute, I saw one question. Hello, will we get the recording copy? Yes, I have requested the IT person to record this session as well. Could you do it once again? Dr. Rabia, would you please say once again which step are you addressing this to? Which step I have to do that again. The frequency, all right. All right, so in order to run frequency or in order to get the measurements on frequency in SPSS, you just go to analyze, descriptive statistics. Under this tab, you will be getting all of this. So how we run a frequency? We select the variables we want, we drag and drop or we use the arrows as per our need. Then we explore this all styled dialog box, as in with the statistics, we can get this all measurement level at once. We can get the quantiles as well, standard deviation, minimum, maximum, skewness, kurtosis. Then we hit continue. After clicking all the checkbox, you hit continue. Then if you want to explore this all other dialog box, you can explore by that as well. And just hit OK. So this is how you get the frequency of the variables you have selected as per your need, as per your analysis. And you do get a simple separate frequency tables for each and every one as well. Over here, as you can see that in the marital status variable, we have valid unmarried, frequency level this, and so on. You get the cumulative percent as well. Okay, so this is how you run a frequencies in SPSS. Now about this all dialog box, these are all shortcuts. You can see you can redo, undo with this option as well. This is a shortcut recall dialog box. As you see that recently frequency we have run. So we have got this. Now in case if you want to the charts as well as per your needs, you can just come over here and explore this small dialog box, which is known as in charts. You can get the bar, pie, histograms. You can get the histograms in one click as well with the normal curve. I'll give an example of that as well. Selected the file and format is not that much useful, and bootstrapping as you can do as per your need. You have to just click OK. So again we have run the frequencies for our variables we have selected, but this time we have got the charts as well in one click. Okay, so this is how your output will look like in SPSS. Click and click on the edit option. You'll be getting this dialog box, or either you can just double click it. You'll be getting this side pane toolbar, which is also a latest enhancement. So over here you can change the font as per your need, as per a requirement. You can change colors and so on. Okay, so right now you can just select it randomly the part and just click cancel. So whatever changes you do, it will be automatically populated in the background. All right. Once again, how you edit your output in SPSS, you just double click it. Okay. You can also, your SPSS does offer these all other types of options for you to make your output little attractive. You can add borders and so on. So I request everyone to do explore these all things, small, and to come with some queries so I can assist you with that. So this is how you can edit your output in SPSS. Now, if you want to share this output, you can either cut, either copy, or copy as in Excel worksheet. I'll give you an example. How does it look like? As per your need, you can do this. You can copy it as in plain text or an image. These are all presentation quality. Okay. So this output, whatever you get in SPSS, is totally output quality. Sir, can we go to the title show? Yes, you can, sir. You have to just click over here. And I'm so sorry, I didn't get the question. Title. Can you go little slow? Okay, I'm so sorry. All right, I'll try to. So if you want to export your output from SPSS, you can just either right click, you can cut, copy as per your need, and directly export into Word or any formats if you want. Again, this in order to explore edit the chart, just double click it. Once you do, you will be getting this legacy dialog box wherein you can do certain changes. These are all the options SPSS offers you. to make your chart little attractive. Okay. So this is how you run a frequency. Kindly sum up initial information as I've joined late. So I haven't done a lot, sir. As Suman ma'am, I've not done a lot. I'm just going through the basic as well. Till now, we have just covered how you define certain things in SPSS, how you can use these all options, menu driven options. This is the data view, variable view. This is the view wherein you can define your variables for your analysis. This is the first step. Once you import your file into SPSS, you come over here and define your variables as per your needs, because this is how your analysis will be depend upon your variable. Now I wanted to show you a simple example once you import an Excel file in SPSS. So in order to import any file in SPSS, you go to File, Open, Data. With the drop down menu, we'll just select Excel. This is the demo Excel file. So whenever you open a Excel file in SPSS, you will always getting this dialog box, as in open dialog prompt, wherein I request everyone to just go through this all options, whatever SPSS gives you. This will be important. So example I'll give you, you can read variables name from the first row data as well, or you can define the percentage of value, determine the data type with the specified, or as per your need you can define the confidence interval. So you can ignore or hidden rows and columns by just clicking on this checkbox. Then you can remove any leading spaces. Over here you can see example. This is a leading spaces example. Okay. So in order to remove that, you can use this dialog box just by one click. You can remove the trailing spaces if there is any in your data set, and just click OK. So make sure you remember this whenever you import any Excel file in SPSS, you will be getting that prompt wherein you have to just click as per your need and do some changes in your. So I see a question with Rabia, Dr. Rabia. Just a minute. You said there are two options available for chi-square test. One is in cross-step, another in non-parametric. Does both come up in the same analysis? Yes. But with this analyze non-parametric test, the legacy dialog box, the chi-square test. Just a minute. That test this non-parametric test will only be visible if you have opted for the exact test add-on module only. So as I told you that if you opt in with the exact test add-on module, you will be getting this dialog box or these options, or you won't be able to see that. And this chi-square test will provide you certain other options like an exact Fisher test and the Monte Carlo method. So this is the two additional methods to do so, which I was talking about the exact test add-on module. Sir, can you again make us go through how to go frequencies? Sure, ma'am. Sure. You go to analyze, you go to descriptive. Descriptive is the place where you can get the descriptives and the frequency. To get the frequency, we select frequency, we drag and drop the variables we require. We go to statistics. If you want some more measurement at one click only, we explore these all options and just click OK. The output is ready. So I've run one discrete frequency once again and again. I see some other questions as well. Let me just address it. Sir, this session recorded. Yes, sir, it is. How to make constructs from questionnaire? Please tell. Constructs from questionnaire, ma'am. I would require you to please do. In this session, I won't be able, because I won't be able to meet the requirement till now. But I will park this question in the later on session if we have any time left, or if I try to address this one, I'll be behind the schedule. So, Miss Shubhi Sharma, I'll address this question later on. You can do that as well, but there is a process. You need to follow a flow for that. Okay.
Okay, sir. Thank you very much. Thank you.
So this is, and one more important thing, whenever you create a new variable in SPSS, it will be shown you under the right end. Right side in the end, you'll be able to see the new variables, whatever you have created in SPSS. Okay, this is also an important thing. Now same, if you want to run some descriptives, you go to analyze descriptive statistics, descriptives, and select the variables you want the descriptives on. You will select all the scale variables or any scale variables. Again, we can toggle through this options, as in one click we can get this all measurement levels. In just one click you can display the order as per your need. Explore this, just hit continue, select those variables you want. And one more important thing, a unique thing about SPSS, now whenever you do open any dialog box, you will be getting this small checkbox every time or sometime or in some dialog box. Make sure you explore this from your end. What this do is, as in you can see that this, if we click this dialog box, it's gonna save the standardized values of the variables we have selected over here. So you can see that in one click you'll be getting the standardized value for the variables you have selected over here, and just click OK. So as you can see that this is the descriptive, how it will look like. The number of variables we have: range, minimum, maximum, sum, mean, standard deviation, variance, because we have selected this variable measurements. Then I was talking about the standardized value. So you can say that in one click I have got the z-scores, as in the standardized values for the variables I've selected. So this can be concluded as a small hack in SPSS. So you don't need to calculate the z-scores or standardized values for your variables. You can just be alert whenever you open any dialog box and just click through some small checkbox so you can get some calculated variables in just one click. All right. So I see one more question. Sir, again, please little slow. All right. Sorry, ma'am. So sorry. Okay. So let me just close the output. So whenever you close an output in SPSS, it will give you an option. Do you want to save it or not? For this purpose, we won't. So how you run a descriptive in SPSS? We go to analyze, we go to descriptive, and we go to descriptive. We select the variables we want the descriptive statistics on. We select those. We go to options, explore this. Once we have done this, we see this checkbox in this descriptive to get the standardized value. We select this. Once I've already done, I won't select this again, and we just hit OK. This is how you run a simple descriptive. Now I see some question. Will we get this recorded copy for the use? Yes, you can. So can you please tell how to upload Excel sheet? Okay, what is the use of getting standardized value? So standardized value is nothing but in order to standardize your variables into a certain limitation, example 0 to 1. This is basically used in machine learning or in advanced analysis, wherein you see that your variables are really high or really low. You make them standardized, as in you give them a criteria between 0 to 1. You scale down your variables and you then do analysis on that. This is something advanced analysis is used for. Then how to upload an Excel sheet? Yes, how you can import an Excel sheet in SPSS. The same way you do for any file. You just go to file, open, data. Then in case if you have any Excel sheet in the same directory or in your system, this is one way you can do this. You select the Excel file you want, hit open. You get this small dialog box wherein everyone is requested to just read on what it is written. Example, you can remove leading spaces or trial spaces and just hit OK. So now this is how you can import a simple Excel file in SPSS. Okay. So this was all about the frequency as an other thing. Then again, I'll show you a simple example how you can use charts. So while giving you an other options wherein how you can do certain analysis, I will be showing some more example on graphs. Let me just give you some simple one. Just a minute. How? Just a minute. I see one more. Sir, how the address variable can be standardized? Good question, sir. I haven't done this, so I have no idea about this, how an address variable can be standardized. A string cannot be standardized, first of all, as per the statistics point of view. You cannot standardize a string value or you cannot standardize any alphabets. Standardization can be only done to a numeric value. So you cannot do standardization to an address. But yes, if you recode your address variable into some numeric format, then you can standardize it. But you cannot do that. Okay. Let me give you some example of graphs, how you can easily create graphs in SPSS. It's very easy. You go to graph, go to chart builder. This is the dialog box you'll be getting once you go to the chart builder. Now this is the canvas wherein this is in the small bottom. If you see, you can see these are all the types of charts or visualization you can create in SPSS. You can create bar, line, area chart, pie, polar, scatter plot, histograms, high, low, and so on. So these are all the types of visualization you can create. Now if you want to know which type of what it is, you can just hover it over, as you will be getting a small pop-up, as in this is a simple bar chart, then this is a clustered bar, stacked bar, simple 3D, and so on. So if you want to know what all type of bars this represent, you have to just hover it over and get to know what this type of a bar it is or a chart it is. And let me give you a simple example how you can create a bar chart. So in order to create a bar chart, you select the chart of variables, you drag it and drop over here. Now you'll be getting x-axis, y-axis, as per your needs you can put it. Now I'll just use the income category. Dropped it in the X menu. As you know, the bar is for basically categorical type of data as per. Now you can create or you can do some changes as per your needs. You can explore these options. You can make your chart more attractive or more colorful as per your need. These are the options SPSS provides you. You can get the statistics as well in those and just hit count. Okay. So this is how you can get or you can create a simple visualization as per your need. Again, I'll repeat the step. How did I created this? Go to graph, select chart builder. This is the dialog box we get over here. I'll just reset it everything. I drag the type of chart I require for my analysis. I drag and drop the variables I want to see or visualize. I can get the statistics as per my need. These are the other options SPSS provides you. I can make the chart appearance colorful as full as per my need and just hit OK. This is how easy for you to create a graphs in your analysis and do some research on that. Now, does anyone has any question?
So graph can be done for all type of string and all numeric and everything, no?
Yes, as per your need.
Okay, because you just did only for string, so I thought. Okay, thank you.
So while creating a graph, there are certain rules we need to follow. Okay. So I request you to just watch a small video or YouTube, as in the rules you need to follow to create or get into data visualization. As if you want to create as per your need, you have to do some customization. You have to recode some variables as in string. variable if you have to just recode it into a numeric one, or you have to give some categories or provide some bins, and then you can proceed ahead. So there are certain rules as well. Request you to please follow that while getting into graphs and all.
So I had a question. All these data is getting saved in the software itself, or we can save it in
So
different
when
format?
yes, that's a nice question. Good question. So when I'm working on this, as in this demo data set, I created this 4 values as per my need. Okay. So once I import this file into SPSS, now it won't be saved into your file. Okay. That is not the case. You have to come here. You can also save it into your file as well, or you can directly export this new data set into a different format as well. You can come here, file menu, you can export this data set into a specific data set. So you can, next time, you don't need to do again all of this measurement, you can directly work on this data set. All right.
Okay, thank
Sir,
you.
sir, this is Silverson, sir. For this data, I need only gender, age, marriage status, education, occupation, income for frequency and percentage.
I'm sorry, sir, I didn't get your question.
Sir, among this data, I need only the frequency and percentage of gender, age, marriage status, education, occupation, and income. So, could you please tell me how to make it better for this analysis, sir?
You needed frequency on certain variables, right?
Yes, sir, and percentage also.
Percentage as well. You can
Yes,
select the
sir.
variables this way. You wanted
Okay, sir.
just age as well, you want frequency, but it is a
Yes,
scale
sir.
variable. You remember that frequencies are basically used for the variables which are categorical variables, because a scale variable you need the descriptive
Okay, sir.
format. Okay, so in data analysis this is how it
Okay,
is
sir.
used.
Okay.
But for your case, I'll still select the
Okay,
age
sir.
variable, income category, vehicle, gender as well you said. Then you wanted the frequency
Okay,
and
sir.
percentage as well. These are all the
Yes, sir.
options you can get as per your need.
Okay, sir.
Percentiles, quantiles, you can provide a cut points and just hit OK. So over here you can see that percentile cannot be get in one click, because for percentile you have to give the range for which you have to specifically define for your variables where you want to give percentiles. That's the one thing. So you have to do this manually or create a new value, or you
Okay,
can
sir.
see, just a minute, if I remove this, will I be able to get percentage? No. So for percentage, you have to provide certain values to get the percentage of that, and just hit OK, sir, as per your need. Nothing else.
Okay,
How
sir.
it is. You can, this small dialog box you can see. If you don't want
Yes, sir.
frequency tables, you can just click and unclick as well. This is a small hack in SPSS.
Okay,
Okay.
sir.
Now, in case if we don't have any question, we can go for a 15 minutes break, because as per the schedule, okay, ma'am, Radha ma'am has some question. I tried some random data. May I please share the screen? Ma'am, if we go get into that, we will be very left behind with the schedule we have to follow. I can do that. We can just get back into by after 15 minutes. I request everyone to take a tea break. It was supposed to take in at 12:15. All right. So from now 15 minutes is
Okay, sir.
around 12:40.
Thank you, sir.
I request everyone to
We'll
just
back
get
after
back
15
by
minutes.
12:40 so we can resume the session.
Thank you, sir.
15-minute tea breaks for each and every faculty members. Please go for a tea break and we'll get back to at 12:40. Okay.
Gaurav sir.
Hello.
Hello. Gaurav sir.
Yes.
This is very exciting. I just wanted to know if you can share the schedule for today's, because at after now it's 12:30.
Yes.
Then
Yes.
what about 12:45? What you are starting? Then it will be a more excited just to know, because this is very exciting and very interesting things you have started anyways. Just wanted to know the further schedule, if possible. Can you share the same? I don't
Yes.
have right now. If you have already shared, can you please share it again? Thank you very much.
All right, sir. Well, once we get back, I'll show you the schedule of what we are going to learn today as well. All right. So I'm glad that you like this session. I'll just share it with you on the screen itself. Okay.
Thank you.
So
Thank you.
you're welcome. So we'll get back. We'll come back by 12:40. Request everyone to just grab a tea. Sure, sure, sure. All right. All right. So I hope each and everyone is back after the tea break. Just give me a confirmation if everyone is back after the tea break. A yes would be perfect in the chat box. Thank you. Thank you. So I think like everyone is back from the tea break. Now, as per sir as requested to just see the schedule which we're gonna follow. Let me just share my screen. I request to provide me a confirmation that my screen is visible to each and everyone. Provide a confirmation in the chat box would be perfect. All right. Thank you so much for the confirmation. So this is the basically the schedule which we're going to follow for the rest of the two sessions. Now we have two sessions where in the first session we're going to talk about this all tests as in compare sample mean compares of means, which is a one sample, independent sample, paired sample test, chi-square, ANOVA correlation. So I'm going to demonstrate how you can perform these all tests in SPSS. Okay, so I think each and everyone can see the session breakout, how what we're gonna follow and what things we're gonna learn in this session now. All right, so let's get back to our meeting. So once we have done with this, now let me just share the presentation. This is the presentation made by our team at SPSS for each and every faculty member who has joined today. So let's start with it. So basically, this is a small overview about IBM SPSS. I guess each and everyone is familiar with this. Then we have a small note we have made for each and everyone that this states that as each and everyone know that every statistical test has some underlying assumptions about your data. All right, so you have to just check whatever assumption your data requires for the analysis you want to do. All right, so make sure you first check the underlying assumption for the test or analysis you are trying to perform in SPSS. You basically check this box as in this assumption is necessary for your analysis, whatever you are trying to perform. So first you have to request it that you check the assumptions of your data set before doing any analysis in SPSS. As the note says that every statistical test has some underlying assumption about your data. If your data does not meet one or more of this assumption, the probability estimates which you get in the output, example, a significance statistics of less than 0.05 may not be valid. All right, so you make sure you check the underlying assumptions required for the analysis you are trying to do in SPSS, and also do check the effect sizes. As in it says that even when a small statistic is significant, it doesn't mean that it is substantially or important. Okay, so always assess the size of the effect you are when you are getting the significant result. This is core statistics. I won't get into details, but just a small overview for everyone. Okay, as in this note says that even a small effect size can be important if it means the difference between life and death. This is specifically for clinical or pharmaceutical or any drug related problems. Okay, then we have a next slide which states that I've just team has prepared as a small online textbook wherein you can get the extensive applications as in explanations of the statistics, wherein checking the underlying assumption. This is the website you can refer to or a link you can refer to. I'll just copy this and paste it in the chat box for each and every member, so you can refer it to later on. and a small note. Okay, so this now small note is basically for terminologies, as in you know that dependent variable is also known as in response variables, which are those variables wherein you expect to measure some effect. Then independent variables are sometimes also called as factors in SPSS. We will be coming across this. What are these independent variables? These are those variables wherein you expect to have some effect on the dependent variable. A simple example is also defined over here. If you think that males will be taller on average than females, then sex will be our independent variable and height will be a dependent variable. So this is just a small note on the terminologies you have to be familiar with. Okay. So what do you do when your assumptions are violated? Do not need to panic, as there are some other statistical tests you can use wherein they compare the medians instead of the means, and do not assume the normality. I hope everyone is familiar with the normality of your data, a bell curve, okay, which do assume the distributions of both groups are same, example positively skewed or both positively negatively skewed. So these are the tests you can perform for Wilcoxon signed rank test for dependent and paired sample t-test, and Mann-Whitney for independent sample t-test. I still see people are joining in. Let them in, okay. So this is all about a small note on assumptions when it is violated, and these are all the analysis which we'll be looking into. And with each of the analysis you are looking over here, we're going to solve a problem with that. So it will be easy for you to understand as well in what domain you can use. This is just a small overview. I'm going to show you how you can use this analysis into SPSS, how you can run. So let's start with this. So the first analysis which we're going to look at is known as in one sample t-test. A small overview of the procedure, what it does. It does test the difference between a sample mean or a known hypothesized value. It also allows you to specify the level of confidence you want in your analysis. And it also produces a descriptive statistics. So the question we're going to solve with one sample t-test is a production line problem. Okay. So over here you can see that a manufacturer of a high performance automobiles produces disc brakes that must measure 322 millimeters in diameters. Okay. Yes, sir, you can get this PPT. I will make sure I share it with you. So what do? They say that a manufacturer of high performance automobiles produces disc brakes that must measure 322 millimeters in diameters. So the quality control randomly draws 16 discs made by each of the 8 production machines and measures the diameter. So the data set is saved under this break.sev. Let's go ahead and open that data set. How do you open a file into SPSS? We go to file, we go to open and data. Here we're going to search the file breaks.sev, which we have data into that, and we're going to open. So this is how the data set looks like. For the confusion purpose, let me just close this output. All right. So this is the data set which we're going to use a one sample t-test on. We have two variables wherein one is machine and one is brake that measure diameters. We have 8 machines which we have randomly drawn 16 samples from. Now let's go back to our case study and see what it says. Okay. So in this case study, this is about the data set. So in this data set, we have a nominal variable first of all, which is known as a machine number, which identifies the production machine used to make the disc brake. So because this data from each of the machine must be tested separately as a sample, so they are requesting us to first split the file into groups by machine number. How do you do that? This is the steps you have to follow to split the file. Okay. Now let's go back to the software. How do you do that? We go to data. We see an option known as in split file. So we're going to split our variable known as in machine number. So we can compare the each 8 production machines separately. Okay. So we select over here compare groups. We drag and drop the variable which we want to be grouped on. and we just hit OK. So in the background now our variable has been separated by the groups. Now we go back to our case study and follow the rest of the steps. So we have followed the steps. We went to menu, data, split file. We selected compare groups and the machine number we want split on. Okay. So we have treated each machine as a separate sample. For this we needed to split the file. We have done that. Now let's go ahead with the next step, how you can do one sample t-test in SPSS. So this is the step 2, wherein how we go to test the sample mean against a known value. We begin with the one sample t-test menu. Where do we find that? Let me just show you. We go to analyze, compare means. In this compare means option, we'll be getting all of this test. One sample, independent, paired sample, one one, and so on. So we go to analyze, we go to compare means and one sample t-test. So over here, we are requested as per the case study. If you see, I won't take it to you again and again. I'll just follow all this step in one go. Okay. So we have to first select the desk diameter as a test variable. It says we go here, select the test variable 322, which is our hypothesized value. We select the test variable which we want to do the test on. And then the case studies also suggest us that we go to option and perform a 90% confidence interval percentage for this test, for this case study. So we go to options over here. We make this 95. So generally, as in an automatically, SPSS always calculate the 95% confidence interval for each test. So for this case study, we have just selected 90% as per our need. Okay. So we do that. We have defined the test value we want to test on each 8 machine numbers which have separated, and we just hit OK. And we have got the result of one sample t-test.
Sir,
Yes.
I just wanted to ask, why did we select test value as 322?
Okay, good question. So ma'am, over here we need to check, as the production line problem, as this case study suggests us, that we need to check if our 8 machines are properly producing the disk as per our defined value or no. Okay, so this is a disk manufacturing company which produces a disk which must measure 322 millimeter in diameter. Okay, so over here quality control, what they are doing, they are just checking if the each 8 machine is producing the disk break as per our need or no. So you can say this is a quality test kind of a thing. That's why we have selected the specified value of 322 millimeter. I hope this answers your question.
Yes, sir. Thank you.
You're welcome. So over here, this is a small definition about the output which we are getting from this test. Okay, after performing this, you can see that these are the tables we get. We get one sample statistics, wherein we get the number of samples, the mean of the 8 machines, tested sample, then standard deviation, that's standard error. This is the one table. Then we get one sample test in which we get 90% confidence interval for the difference we have mentioned, and the effect sizes. Okay, now let me just do a small.
Just a small request. If you could go a little slow and explain how to interpret this data.
Sure, ma'am, I'll try to do that, and I'll just try to go a little slow as well. So ma'am, interpretation of this output is totally depend upon you, what you are looking at, what question you are trying to solve, or what hypothesized value or null hypothesis you have in your mind. Okay, so it is basically as per the statistic view, it is requested everyone or whoever try to do any statistical test is to first write down on a note of paper that what is your null hypothesis and what is your alternate hypothesis. You have to first mention that on a piece of paper, then you can proceed ahead, so you won't get confused later on. So about the interpretation about this one sample t-test, I'll give you an example of that as well. So as over here, you can see this is the mean of the 8 machine numbers, is the number of samples 16. You can see that with the mean value of first machine, we are getting 321 as in the average value of that 16 disk. Then for the second machine number and so on. Now, if I get back to you with the what we have prepared for you as in a small note on this, The descriptive statistic table, it displays the sample size mean, standard deviation, and the standard error for each of the 8 samples, which says that the sample means disperse around 322 millimeter standard by what appears to be a small amount in variation. So that's what it says, that after looking about this, you can say that there is a small dispersion around the specified value you have given for the test. Okay. If this would be a 320 or 319, it will be a small, large dispersion. But looking at this value, you can say there is a small dispersion in that only. Okay. Now, if we get back to the one sample test dialog box, as in this output, the interpretation would look like this way. So that what does the result shows? It shows the one sample t-test first of all, which states that where the confidence intervals lie entirely about 0.0, you can safely say that machine 2, 5 and 7 are producing disks that are significantly wider. How do you define that? Let's go back to the output. So over here, by looking at this confidence interval, what it says that whoever's confidence interval lies above 0.0. Okay, so this is about 0.0, machine number 2, then this machine number 5, 0.0, it lies above 0.0, then again for the machine number 7. So looking at this statistics, you can say that machine number 2, 5 and machine number 7 are producing disc breaks that are wider than 322 millimeter. Over here you can also see that machine number 2 has a mean of 3.2032 or 322 plus some value. Same machine number 5, 322 plus more some values. So you can conclude as per the interpretation that this machine number 2, 5 and 7 are producing discs that are wider than the specified value which we need for the machines. Okay. Same again it goes for the other way around. If you see the confidence interval which lies about 0. In minus, you can say that machine number 1, 3, 4 or 6 are not producing that wide enough disk as per the specified value, which it is written over here. Okay. So for by the first line, I guess it is clear that you can consider that machine number 257 are producing discs that are significantly wider than the 322 millimeter on average. And similarly, because the other's confidence interval lies entirely below 0.0, it suggests us that machine number 4 is not producing discs that are not wide enough as per our output. So as you can see, machine number 4, we have a minus confidence interval, which suggests us that machine number 4 is not producing disk which is against the value which we have specified or which we need for our production. So that's how you can interpret through our or your case studies. So in your terms, in your research or your analysis, it will be totally different. Okay, so it's your duty to just get some statistical knowledge and then interpret to the results. I guess no one has any other question, and effect sizes is just a smaller variation which we had, or you can say you have to just I request you to just go ahead and search for what is effect sizes. It is nothing but the impact of the, what do you say, production in the change. So that's how you can interpret to your output from the one sample t-test or any test you follow. That's how you interpret it. You have to look through the values very closely, which is giving you what. If you look at the significance level as well, you can see that you are getting very low significance level as in the perfect significance level for machine number 2 and so on. So this was all about the one sample t-test. I guess now everyone can perform one sample t-test in SPSS. It's very simple. I'll just let you through these steps once again. You go to analyze, you go to compare means, select one sample t-test. You will be getting this dialog box. You have to just specify if you want to test a certain hypothesis. You give the value over here. Select the variables you want to test on. Give the confidence interval as per your need. Here it was 90%. Continue and okay. Your one sample t-test will be done. Anyone has any question how you can perform one sample t-test?
Hello, sir.
Yes.
Can you explain the concept of splitting again?
Sure, ma'am. Splitting has to be done as per your need, first of all. So why did we split that? I'll give you an example for that as well. If I go to data, split file and just reset our values. Okay, over here we are not splitting our data set. We are just testing all of these variables against this. Now let me run a one sample t-test for you without splitting the file. Everything will be same. I just hit OK. So now we are getting the test value for overall column. Okay, so overall column is considered as a one machine which is producing a disk. We are getting the mean of overall column over here and so on. By splitting the file, what we did, we just tested 8 machines separately. Over here, we have the one sample t-test consider that yes, whatever values you're getting from that, it is from the one machine itself. So that's how the need of splitting file comes in this case. So in your case, it can be different as well, totally different. So this is just a small example how you can utilize the data and transform menu as per your need. You got it? I hope this answers your question, ma'am.
Yes, sir. So basically, splitting gives us data on each of the domains that we're testing, right?
Yes. Yes. Each of the 8 separate machines, we are testing it separately. But over
Okay.
here, if we don't do the splitting, we are just testing that all values as in coming from one machine. But after defining or splitting the file, what we have done, we have just tested all of the values for it separately.
Okay.
Okay. Now this was all about the one sample t-test. I won't save this. Now let's go back to the case study. This was all about the one sample t-test, how you can perform and do a small interpretation through it. Now let's go ahead and look at the paired sample t-test, how you can perform it into SPSS. Okay, so the paired sample t-test procedure, what it says that it is used to test the hypothesis of the number of difference between two variables. The data may consist of two measurements taken on the same subject or one measurement taken on the matched pair of subject. Additionally, this procedure offers you these all things. Let's go into the case study and see what question we can solve with paired sample t-test. So the question we have to solve with the paired sample over here is, does a diet make a difference? So over here, the problem statement we have is a physician is trying to evaluate a new diet for her patients with a family history of heart disease. Okay. So now to test this effectiveness of this diet, the physician has put 16 patients on a diet for 6 months. He has measured their weights and the triglyceride level, the chemical level for heart disease. They have measured before and after the study, as in before and after the diet. And now the physician wants to know if either set of this measurements has changed over the course of time or no. Basically, does this diet make a difference to my heart patients or no? So the data is saved under this file, as the name goes in the diet study. Let's go ahead and open that. How you open a file in SPSS? File, open data. So what's the name of the file? Diet study. We open it. So this is how our data set looks like. Let me just previous one. Okay. So this is our data set, how it looks like. This is the name patient IDs. This is the age of the all 16 patients. Their gender, TG0 to TG4. TG0, if you hover it over, you can see that this is the initial triglyceride level before the diet, and this is the final triglyceride level after the diet. Same goes for this weight variable as well. This is the initial weight variable before the diet, and this is the after the diet. If you go back to the case study, these are the steps. Just look at it. I'm going to perform it in one go. It's very simple. We go over here, how you perform a paired sample t-test. We go to analyze. We go to compares of mean. Over here we see the paired sample t-test. We click on this, we get this dialog box. Now if over here we have to select the variables we want to test on. We're going to select the triglyceride level, the initial triglyceride level, and the final triglyceride level after the diet. Same goes, we're going to measure for the weight as well for this case study, the initial weight and the final weight after the 6-month diet. Okay, I just did a small error. I'm going to reset it. Initial triglyceride level, final triglyceride level, initial weight, and final weight. Okay. Again, we can give a confidence interval as per our need. But in this case study, we don't need to. We have to just click OK. We have got the results of the paired sample t-test in just few clicks. So that's how easy it is to use it. Now again, as per the interpretation, you get this all dialog box wherein we first did the paired sample statistics, in which we get mean, number of samples, standard deviation, and the standard error. Then we do also get the paired sample correlation. Then we get the paired sample test results and the effect sizes again. Now let's go ahead and see how you can interpret it through these results. So as per the interpretation, the descriptive table, what it says, it displays the mean, sample size, standard error, so on. So what it says that across the 16 subjects, the triglyceride level dropped between 14 to 15 points on average after 6-month diet. And how do you conclude that? After looking at the mean value. If you see, the mean value of the initial triglyceride level was 138. And after the diet, the final triglyceride level was 124. So you can say that the drop down was between, after the diet, was around 14 to 15 points in the mean. Same goes for if you check for the weight. The initial weight of the patients were average were about 198 pounds, and after the final diet was 190. So you can say that after the diet, people have lost around 8 pounds of their weight after the diet. So this would be a small interpretation. Alright, so which is written over here. Again, if we look into the paired sample correlation box, just a minute. Okay, so this is about the Pearson correlation. As everyone knows that correlation is measured between -1 to +1. If you get the -1 value, it is strongly uncorrelated, and if you get some values into above 0.1 or into 1, there is certain correlation. So this, what it says, that at -2 0.286, the correlation between the baseline and the 6-month triglyceride level is not statistically significant. Levels were lower overall, but the change was inconsistent across the subjects. Several lowered their values, but several others did not change as they increase in their levels. Okay, this is how you have interpreted. So the correlation between the final and the initial is -2.86. So you can say that there is no correlation between the triglyceride level drop down. But on the other hand, if you see the weight variable, the weight initial and the final one, there is a 0.996 correlation, almost a perfect correlation. So which can contribute to the diet. So you can say that the diet was not effective in reducing the triglyceride level in the patients, but the diet was very effective in reducing the weight of the patients. That could be a small conclusion from this Pearson correlation table. Okay, that's what it is written over here. On the other hand, the Pearson correlation between the baseline and the 6-month weight measurement is 0.996, almost a perfect correlation, unlike the triglyceride level. Okay, that's what it is written over here. So that's how you can conclude the interpretation through this tables. Now we have small information on the paired sample test value as well, which says that since the significance value for the change in weight is less than 0.05, you can conclude that the average loss was 8.06 pounds per patient was not due to change variation, and so on. So this would be a small interpretation toward paired sample t-test. Alright, so I do see some questions. I'll address them now. Voice is breaking. I hope I was audible.
Sir,
Yes.
can you please show the paired sample from the analysis table, sir?
Do you mean the output, ma'am?
Just on this only analysis, where did you go on the paired sample?
Sure. We go to analyze. In the compare of means, we get the mere one sample, independent, paired sample, and so on. One way or another will also, you can find it over here.
Yeah. Thank you.
You're welcome. Require recording to proceed with this short. Geeta ma'am, I'll share this. Did I miss any question? We will interpret it using two-sided, yes. As per our need, we can interpret it two-sided or one-sided. It's all depend upon our need. Dr. Rabi is asking TG0, TG1, TG2, etc. Could you elaborate the data again? Sure. So TG0 to TG4 is the measured triglyceride level, first of all. This is the initial triglyceride level before the diet, before the patients were placed on the diet. And this is just again, they were measured after a certain time, after between the 6 month of time, and this is the after 6 month of a time when the triglyceride level was measured. So this is all about the data. I'll show you a place wherein you can get all of this case studies as well in the end. So it will be easy for you to learn SPSS.
Hello, sir. Hello, sir. Am I audible?
Your voice is breaking, sir.
Will you please explain the last slide pair sample test? You have shown it 8.06 figure was there. Will you please explain it again?
You want me to explain this?
Yes. And same like this slide also and the analysis tables also.
Sir, if I get into the statistics, I won't be able to complete the schedule which has been scheduled, to be honest. That's why we won't get into statistics, to be honest. I'll give you a place wherein you can understand the statistics as well.
Okay. No problem, sir. No problem. Okay.
Sure. So it is nothing, just it is a small interpretation written over here, as in the significance level is 0.5. You can conclude the average lost was 8.06 pound in per patient, which was not due to chance in variation and can be attributed through the diet. However, the significance level, which is greater than 0.2 to 10 for change in triglyceride level, shows that the diet was not significantly reduced their initial triglyceride level, which is concluded from this. The significance level after looking at this, where it is. Yes, you can say this or this significance level. That's how they have interpreted. So what do you think when you get a small significant level as per your need, as in a 0.05 less than 0.05, you say it is statistically significant, right? So that's what they have concluded, that the weight is statistically significant, that the diet was significant to the weight, but the diet was not statistically significant to the triglyceride level. That's what a simple conclusion would be. Okay.
So that 8.063 mean value is taken over in that slide, say 8.05.
That's
Okay.
yes, sir.
Okay.
It's from over here.
Okay.
All right. So let's go ahead with the next slide, which we have an independent sample t-test. Okay. So over here, what we're going to do, this is a small description about what this independent sample t-test done, and this is the procedure that also displays. A test in variance, equality, confidence interval you can define as per your over here with the independent sample t-test is this. Testing to independent sample means. So over here, an analyst at a department store wants to evaluate a recent credit card promotion. To end this, they have done a survey wherein they have 500 card holders who were randomly selected. Half received an promoting ad with a reduced interest rate on purchase made over the next 3 months, and half received a standard seasonal ad. So this data has been saved into credit.promo. Let's go ahead and open this data and see how does it look like. Okay, so this is the data set. Let me just close the other output for confusion purpose. Okay, so this is the ID of the 500 people who are randomly selected. This is the type of promotion they have selected. If we go to variable view and see what this 0 and 1 means. 0 we have defined for standard promotion and 1 we have defined for new promotion for the people we have received. Okay, so this is about the type of seasonal ad people are received, and this variable concludes that this is the dollar they have spent on the promotional ad after receiving that. So let's go ahead back to the presentation and perform the independent sample t-test. How do we do that? This is the steps you need to perform. It is very simple. You're gonna go back to our EDIS. We go to analyze, compare means. This is where we find this independent sample t-test. We select that, we get this dialog box. Now we have to just select the variables we want to test on. So our test variable will be dollar spent during promotional ad, and the type of mail people received will be a grouping variables. So whenever you have a grouping variables, you'll if it is not properly defined, you'll be getting a question mark like this. So you have to click the define their groups. As you know that we have selected 0 and 1 for our groups. So you have to make sure you match those values while defining the groups. So we have defined the groups. Continue. Any other options if you want to change any, and just hit OK. We have got the result of independent sample t-test. So that's how easy it was to run an independent sample t-test in SPSS. How did we do that? Just recall it. Select the dollar spent as in a test variable, type of mail as in a grouping variable. We define the groups once again, 0 and 1. We match that as per the data set. Hit continue and just hit OK. Right, so this is the output you get from the independent sample t-test. Now let's go ahead and interpret to this how you can. So I request everyone to just read through this. You will be having a brief idea about that. So first, the table which we get, the group statistic table, the descriptive table, it displays the sample mean, standard deviation, standard error for the both groups. What we have concluded from this, that on average the customer who received the interest rate promotion charged about just $70 more than the comparison group. That's where it can be seen. Just looking at the mean itself, you can say that the people who received the standard promotion has spent this, and the people who have received the new promotion has spent this much amount, which is an average amount. And if you calculate the difference between this, you can easily conclude that the people who have received new promotion has spent $70 more than the people who have received standard promotion. Okay, so that's how you can conclude a small interpretation which is written over here. Same goes for the descriptive independent sample t-test as well. So that's how you can interpret it through your output. If there is another thing with any researchers or any analyst is looking at, he can conclude as per his need. Okay. Now, is there anyone have any question how you can perform an independent sample t-test? You know how easy it is? Dr. Abia, I missed your question. So sorry that Pearson correlation is interpreted by 2 pill. Yes. Please share the PPT. Sorry, I missed. Sure, I'll share this with Mita ma'am so she can share it to all the faculty members. Anyone has any question how you can run a simple independent sample t-test in SPSS? A yes, no would be perfect in the chat box. I guess everyone can perform, right? Perfect. So now let's go back to our now perform an chi-square test in SPSS. Alright, so chi-square test, as I told you, that it is a cross tabulation table, which is a basic technique for examining the relationship between two categorical variable. It can be nominal or ordinal as well, possibly controlling by additional layer. I'll show this additional layer thing. So this is a small note about what the cross tabulation offers. It offers independent and measure of association and so on. This is a detailed statistics basically. Now using the cross tab, what question we're gonna solve is we're gonna study a nominal by nominal relationship. For this, the data set is stored under satisfy, satis f.sav. The question we have to solve over here is this. In order to determine customer satisfaction rate, a retail company conducted survey of 582 customers at 4 different store locations. From the survey result, you found that the quality of customer service was the most important factor to the customer overall satisfaction. So given this information, we want to test whether each of the store locations provide a similar adequate level of customer service or no. So for that, we first go to back to our SPSS. We open the data set which we need, which is known as SATS. We open this data set and close the other data set output just for confusion purpose. Now this is a survey data, okay? I'll give you one more hack how you can define which is what. If you go to variable view, you can see that each and every variable is a categorical variable and it has been recoded. Okay, first gender, we have defined 0 and 1 for male and female. Then further question as in age category, we have defined some categories into 1 and 2, 3, 4, defined it as per our need. For other question as well, we have defined each and every variable as in categorical and we have decoded it into numeric values. Alright, so this is how you can decode a string value into a numeric value. Now, if you want to see over here as well, you see this shortcut over here, which is known as in value labels. If you hover it over, if you click over here, you can see all of the string values which has been converted into a numeric form. Alright, so this is how this shortcut is useful for. Okay. So as this is a survey data, we have gone into variable view and defined our variables as per our need. Now let's go ahead and perform a chi-square test. So as per the case study, what we need to follow? To run a cross-tab analysis from the menu, we go to Analyze, Descriptive and Cross-tab, which I've already showed you, which is over here. We go to Analyze, Compare Means, Descriptive Statistics and Cross-tab. Okay. So over here, what we're going to select the variables? We're going to select store as a row variable and select service satisfaction as a column variable. Let's go back to this. We're going to select store as in a row variable and service satisfaction, which is this variable, as a column variable. Now, in case if anyone remember, as per the case study over here, you can also possibly add a layer variable to our variables, which can be done over here. By this column, you can add a layer as well. I'll show an example for that as well. Again, I told you as a small hack in SPSS, you can display the clustered bar charts or suppress the tables as per your needs in just one click. So what the case study says, it says that then we have to go to statistics and select these all measures as in the chi-square, contingency coefficient. These are all statistic value. How do we do that? We go to, no, we don't go to exact. This is also the same test you get from the non-parametric test if you go to the exact test add-on module. So in order to perform the chi-square test, we need to go to statistics and make sure you hit this dialog box, the checkbox as in chi-square test. Then only the chi-square test is going to perform. Okay. So as we are checking a relation between a nominal and nominal, we have SPSS have separately defined you the measures you can get. For nominal and nominal, you can select all of these values and check the relationship. If you have any ordinal values or ordinal variable, you can go with this. If you have any nominal with interval, you can go with this measurement. Okay. We can also get correlation as well as per our need, and just hit continue and okay. So this is the output of chi-square test will look like. You get one case processing summary every time, every analysis you do. Then you get store by store service satisfaction, wherein this is a survey data, wherein these are the strongly negative, somewhat negative, and so on. If you overall only see that which store has got the most strongly positive feedback, would be this. You can say that store number 4 has major number of people who are positively satisfied or strongly positive with the service they providing. Same if we go to the strongly negative, you can say that store 4 is the only one who is getting the highest strongly negative value as well. This is an overview of interpretation. Okay. Let's go ahead and see what our case study tells us. So the case study tells us the cross tabulation table store by service satisfaction. It shows you the frequency of each response or each variable. If each store location provides a similar level of services, the pattern of response should be similar across stores. That's what it says. As you can see that at each store, the majority of response occurs in the middle. Store 2 appears to have fewer satisfied customers, and store 3 appears to have fewer dissatisfied customers. Over looking at this, you can interpret it that store number 3 has very fewer dissatisfied values. Okay. Then further ahead, is there any interpretation given? Okay, yes. So we have also described the chi-square test for store by satisfaction. So the chi-square test measures the discrepancy, as you know, between the observed cell counts and what you would expect if the rows and columns were unrelated. So over here, the two-sided asymptotic significance of chi-square statistic is greater than 0.0. So it's safe to say that the difference are due to chance variation. Okay. So however, there is a small note that not all customer might have surveyed actually and had a contact with the service representative. So the ratings from these customers will not affect the actual quality of services at the store. So over here, we're going to further classify by adding a layer label. So to that, what we do, we're going to add a layer label over here. So this is the steps how you can do that. Let me go back to the case study and show you how you can do that. We're going to recall the cross tab menu and we're just going to add a new layering variable, as in does all customers has interacted with the service representative. So over here, we might have a just a minute. Contact with the employee. So this way we're gonna add it as in a layer variable and select it. Okay. When we add a layering variable, now our table is further classified. These are for all the customers who have not contacted with the service representative, and these are all the people who have contacted with the service representative. Okay. So that's how you can add a label wherein our table has been further classified. All right. So now interpretation about this, we have summarized it over here. I'm going to wait for 2 minutes. I request everyone to just read it through from your end and ask if you have any questions. So this is as per your need, you can interpret it through the output in SPSS. So in your case, it will be totally different. That would be my point of view, because each and every analyst or a researcher might be trying to answer a different question. So it is recommended that you do have some statistical knowledge to interpret to the output in SPSS. That will be easier for your understanding. Same goes a small description for the symmetric measures as well.
Hello, sir.
Yes.
It's just a small request. Due to network issues, a lot of content is fluctuating. So, if possible, if we could get the recording later so that we can, follow through.
Sure, ma'am. I
We
will
are,
share the record.
we are going to get it. I just want to
Hmm.
confirm.
Sure, ma'am. I'll make sure you all get the recording of this session. Okay.
That would
So
be really.
let's.
Thank you.
You're welcome. So let's again goes for the ANOVA, how you can perform it. I'll show you that. Let me just check if we are with the schedule. It's already been 1:30 and we are left with ANOVA and correlation. So I want every faculty member to do a poll that do you want to go for a lunch break now or do you want me to cover this topic as well? Just a poll. You can just answer it without, you can unmute yourself or you can just say in the chat box as well. So that you want to want me to cover these topics right now or after the lunch break? The call is yours.
Continue, sir.
Hello.
Sure. Yes.
Yeah. My suggestion, Gaurav, is let's follow whatever is our schedule.
Mm-hmm.
Yeah, this is Smita Shukla. Okay. So, in case you have covered whatever you had to intend, whatever you intended to cover prior to lunch, no, cover that. And then maybe you can go ahead with the lunch break so that you can start with the component which you are planning after lunch.
Sure, ma'am. Sure, ma'am. I'll do that.
Yeah.
So let's go ahead and see how you can perform an ANOVA test in SPSS. It's very simple. Again, you can use one-way ANOVA to test the hypothesis that means of two or more groups are significantly different or not. As you see that testing the equality of group variance over here as an important first step of analysis of variance is establishing the validity of data, as in the validity of assumption, which I told you in the beginning of the this analysis. As not visible, I'm getting a chat as in not visible. Is my screen visible to each and
Yes, it
everyone?
is. Yes, it
A
is.
quick confirmation. It
It
is.
is. It is.
All right. So, Geeta ma'am, request you to please check your internet connection. Sorry for that. All right. So as again, while doing an ANOVA test, you have to make sure the validity of your assumption is met or no. So over here, we're just gonna see how you can perform the example. That's what it written over here. So the question we can solve with ANOVA is that a sales manager wishes to determine the optimal number of product training required for the new employees or no. So he has performance score for 3 groups, employee with 1, 2 and 3 day training saved in this file. So let's go ahead and open this file. We go to file, open data. We search through the file, enter. So this is how the data will look like. Just for confusion purpose, I'm going to close the output. So Geeta ma'am is saying that Excel is not visible, software not visible. Okay, I'll just stop, share my screen and share it once again. Is my software visible now? Okay, confirmation will be required, ma'am. Perfect. So this is the data which we're going to perform an ANOVA test on. How do we perform an ANOVA test? We go to analyze, we go to compare means, then one way ANOVA. Over here, you have to just select the variables we require for our test. So if we follow the case study, to test the quality of variance assumption from the menu, we have to go to analyze, compare means, one way ANOVA. We're going to select score on training exam as in a dependent variable and select sales training group as in a factor variable. Okay, so let's go ahead and do that. We're going to select score on training exam as in a dependent variable, sales on training group as in a factor variable. Again, we got a checkbox to check the estimate effect sizes. This case study doesn't need it. So one thing important about whenever you are doing an ANOVA test, you have to make sure you go to post hoc now, you go to options and select the homogeneity of variance test. If you have not selected this test, the ANOVA test won't be performed. Homogeneity of variance test is the basic a small name for ANOVA as well, which measures the analysis of variance across the group. So while performing an ANOVA test, you have to make sure you go to options and do a check on this homogeneity of variance test. We can also get means plot in one click and so on. I'll just go with the descriptive as well. We hit continue and hit OK. The one-way ANOVA test is done. Now overview again, one more important thing. As per your need in one-way ANOVA, you can add some contrast. If you want to know about this, you can just explore the help menu. If you are not into statistics, you can add some post hoc test wherein you can get this all measurements level. Okay, as per your need, as per your questions you're trying to solve. And make sure whenever you're trying to do an ANOVA test, you click this homogeneity of variance test. I can sense some disturbance. I request everyone to mute themselves.
हाँ ठीक है सर
All right, once again, there was a lot of disturbance. So I request everyone to put themselves on mute. All right. So let's get back. Okay, so this is how you can perform an ANOVA test in SPSS. You have to just select the variables you want to. Dependent will be your response variable and factor can be the independent one, and just hit OK. Now this is the output you get from SPSS. Now it's your duty, it's your prime focus, what question you are trying to solve, and you can interpret it as per your need. So for this case study, what it says, so you can see that the standard deviation and standard error statistics confirms that as the training day increases, the variation in performance decreases. How you concluded this over here. So after a 1 day variation in standard deviation over here, you can see as the number of training days increases, the variation in training decreases. The standard deviation drops. So that would be a small interpretation. Okay. Then again, the test of homogeneity of variance. This is as per your need, you can conclude it. You get certain different measurements level with the core statistics, wherein first is based on the significance level on the mean, then the second is based on the median, and so on. Third with the adjusted mean with some adjusted degree of freedoms. Then fourth is based on trimmed mean. So this is something into core statistics I won't get into. Alright, then you get the ANOVA test with the significance level, so on. So what the homogeneity of variance table says that the Levin statistic rejects the null hypothesis that the group variance are equal, as in ANOVA is robust to this violation when the groups are of equal or nearly equal size. However, you can choose to transform the data and perform the non-parametric test again. That would be normal suggestion after the interpretation, as it is violating our assumption. So this was all about the ANOVA test, how you can perform into SPSS. You go to analyze, go to compare means, and one-way ANOVA. Now let me just go ahead and follow the next, which is the correlation over here. So we're going to follow the case study here again. So over here, we're going to see a bivariate correlation. So what this procedure offers, it computes a pairwise association of a set of variables, which also displays the result in a matrix format. It is useful for determining the strength and direction of the association between two variables. So we're going to use bivariate correlation, or a correlation you can say, to answer this question, as in the study the association between motor vehicle sales and the fuel efficiency. So what the company says that in order to increase the sales, the motor vehicle design engineers want to focus their attention on aspect of the vehicles that are important to customer. For example, how important is fuel efficiency with respect to sales. So one way to measure is to compute the correlation between the past and the fuel efficiency. So the information is saved under the car underscore sales. Just gonna go ahead and open this data set. We go to file, go to open data. We search the name of the file we need for this analysis, which is the car sales. This is how our data will look like. Let me just close the other output for confusion purpose. Okay, so in this data set, we have manufacturer detail, the model detail of the car, the sales value, the resale value, the type, price, and so on. So these are all variables. So let's go ahead the case study and see what it suggests us, the steps we have to follow. So it is very simple to run the correlation analysis. We go to analyze, correlate, and bivariate. This is a software. We go to analyze. We go to correlate. Correlate, in this you'll be getting all the correlation tests which you can perform. So over here we're going to do a bivariate correlation. Here we have to select the variables we need for to check the correlation for. So one way to do that, you can either right click on this variables, right click, and you can display the variable names or only the labels, or you can sort the file in order. Okay, so we're going to select from vehicle type. You can also use keyboard as well. Press shift and just to use arrow to select multiple. So as per the case study suggests us, we have to select from vehicle type to fuel efficiency. Drag it drop over here and just check the percent correlation. Over here, you can see correlation coefficients. For a rank test, you can also select Kendall, Stowe, and Spearman. I'll give you an example for this as well. Again, you can explore this side all menus. So for this test, we don't need to, and we just hit OK. So this is the correlation dialog box will look like, the output. Over here, one more hack I can show you. As you know that correlation table can move, we have to only see the upper half triangle or the lower half. Through over here, you can just minimize the lower half and show the diagonal itself. So we can only focus on the lower part. So over here, you can see the correlation between some variables. As you can see, price in thousands and vehicle type has a minus correlation. Then engine size and vehicle type has 25% correlation and so on. Okay. So now it's your prime duty to again interpret what correlation you are trying to see. Let's go back to the case study and see what it says. So the correlation matrix, this is the description about it. So the Pearson correlation coefficient measures the linear association between two scale variables. So the correlation reported in the table is negative, although not significantly different from 0. And we got a p-value of 0.83, which is greater than 0.10. This suggests that designers should not focus their efforts on making cars more efficient, fuel efficient, because there isn't appreciable effects on sales. Okay, so that's how they have concluded it. So one error we did over here, I'm so sorry for that. So we haven't select all variables which we needed. We're gonna reset it. No one pointed me as well. We have to select sales in thousands and fuel efficiency as an analysis variable. Okay. In the flow, I did some error. Sorry for that. So we're gonna recall it. Bivariate correlation. We're gonna select sales in thousand through vehicle type. Again, sales in thousands and fuel efficiency. We have to select only two variables and fuel efficiency. See that correlations. Okay. So this is how the correlation will look like of the two variables we wanted to check between sales and thousand and fuel efficiency. This is the number of variables, and we got the correlation as in minus 0.7 as in a negative correlation. So that's what the case study suggests us. So that as the p-value is greater than 0.083, this suggests that designers shouldn't focus their efforts in making the car more fuel efficient. So however, the next step of this analysis says that the Pearson correlation coefficient works better when the variables are approximately normally distributed. Example, they are performing a bell curve. I guess everyone knows what a normally distributed variables are and have no outliers. So for this, to check if we have any outliers or no, we can produce a scatter plot and reveal these possible problems. So to produce a scatter plot, we have to follow these all steps. We go to graph, chart builder, select. So let me just perform these steps for you. We go to graph, we go to chart builder, then we go to scatter dot. We select the simple scatter plot over here into the canvas. Then we have to select the variables we need. We want to see on. So the case study suggests us to select sales in thousand as in a Y variable. Okay. Sales in thousand as in a Y variable. And the fuel efficiency as in our X variable. Okay. I guess I'm very clear about what variables I'm selecting as per the case study. Fuel efficiency as in our X variable. That's right. Then it also suggests us to click the group point ID table and select point ID table. I'll give you an example of that, how it can make changes or how it can give you some significant results. Before adding the group point ID table, I'll just run this graph and see how the graph will look like. So we are getting this graph as in we have some outliers, which is a very far point, this and this. Now let's see after adding a group point table, as in doing some changes or some basic enhancement in our graphs. We go to group point ID table. We select point ID table, then we have got this column over here. You can see that. So after doing this, we have got a new variable point, wherein as per the case study, if you see, we have to select model as a variable label cases. So over here, we can name the model. In the variable section, we drag and drop and hit OK. Now what does it makes? It just gives you the name of the other variables. Now just by looking at this, you can see just by making small changes how interactive you can make your visualization in SPSS. So this would be a small tip. You can always just run the graphs completely without any changes. Then you can make some changes and see how interactive it can be. So over here we can see we have two outliers wherein F series and Metro could be an outlier for our analysis. So that's what the case study suggests us, that it can be any outlier. It shouldn't be having an outlier and the variables should be normally distributed. So with this, after developing a scatter,
so can we remove the outlier or?
Yes, the further step is that only, sir. Don't worry, I'm going to show you how you can. So now we're going to split the file and improve the correlation. Okay. So the next step, we're going to do some improve the correlation estimates. For that, we're going to split the file according to the vehicle type. We're going to go to data split file. Again, we go to data, we go to split file, select the compare groups. And as per the case study, if you see, we have to select vehicle type or the variables on which the group should be based. Okay. So vehicle type. All right. Once we have done this, all right, we have selected vehicle type as a variable and group should be tested. Over here, we have done this. We hit OK. Now we are just improving the correlation. Okay. We are not removing the outliers. I will show you how you can do that. So we again go to recall the chart dialog box and we just hit OK. Now if you can see, our correlation has been improved. It has come to positive. Previously when we have just done nothing, our correlation was in minus. So just by doing some tuning to your data set, you can see you have improved the correlation just by adding the vehicle type, as in this is for the automobiles and this is for the trucks. As you can see in automobiles, you cannot conclude truck as well because automobiles are different. Okay. So this is how we have improved the correlation. Furthermore, we are just going to improve our correlation more better. So this is a small correlation matrix. As it says that after splitting the file, we have to just make a significantly fair strong positive correlation between sales and fuel efficiency for automobiles. For truck, the correlation isn't positive but significantly different from zero. Okay, so reaching this conclusion has required some work, as you have seen, and showed some correlation analysis using the Pearson correlation coefficient, which the case study suggests us, which is always not a straightforward. So for comparison, how you can avoid the difficulties of transforming variables by using non-parametric correlation measures. Let's go ahead and see that. So to run a non-parametric correlation estimates, we can use Spears-Monroe and Kendall-Stowe statistics. If you are into statistics, you can easily sense that Spears-Monroe and Kendall-Stowe is used for measure the rank of order association between two scale variables or an ordinal. They work regardlessly of the distribution of the variables. So to obtain this, we're gonna recall the bivariate dialog box. Okay, we're gonna select the sales in 1000 as in analyzed variables and deselect the Pearson and select Spearman. We go to over here, we recall the dialog box, we go to bivariate, we just deselect this and select Spears-Monroe. Okay, that's what our case study says. So now we just hit OK. Now if you can see that the correlation has been improved a lot better. It has given a value from plus 0.262 to 0.418. Easily you can see just by getting some non-parametric estimations of association between two scale or nominal variable, but defining a different test, we have just got some improved correlation between our two variables. So this is how you can tune again and again your variables and get some good correlation between your variables. If you see, this is what it has been described, that Spearman rho is reported separately for automobiles and trucks as with the Pearson correlation coefficient. The association between the, over here they have taken the log transform sales. We haven't took that. We can do that as well. You can just hit the dialog box, deselect these variables, and you can just use the log transform where it is. Yes. Log transform is nothing but we have transformed our values into a certain given criteria. It is an example 0 to 1. We have normalized. Again, this is a method called as standardized normalization. In machine learning, it is mostly used. That's what we get the same results, as in you can see. Okay, so it has nothing to do with that. So this is how they have reported Spearman rule. Same correlation between fuel efficiency is fairly strong. So that's how you can improve your correlation, so on. Further ahead, we can also do some more conclusion. We can remove some outliers and make our correlation more strong. Now I'm done with this correlation analysis. Does anyone has any question how you can perform a by correlation analysis in SPSS? Dr. Rabia is saying, sir, again, please, if you can repeat. Okay, so over here we are nothing, we are just checking the correlation between two variables in SPSS. How you can perform a correlation analysis is very simple. Let me just close the output for you. How you can do some correlation analysis in SPSS? It's very simple. We go to analyze, we go to correlate function, and we select the bivariate correlation, as in we are checking correlation between two variables. Okay, we select the variables we want to see the correlation from, sales in thousands and fuel efficiency, and we just hit OK. We get this value. As further, you can see that we have already splitted the file from automobiles as in vehicle type. That's why we're getting to this dialog box. If we haven't done that, we will be getting a different correlation over here. So but just by we are tuning our variables or our analysis, we can make our correlations more better. We can check if there is any sense. So this is what's all about, checking the correlation between two variables, nothing else. We were just getting into the case study. If you want to know the correlation between more than three variables or so a correlation matrix, then what options do? We just select the variables which we want to check the correlation on. Over two, we can also check the third variables as per our need, or I can check the engine size, the correlation as well, and so on. We can select as multiple values we want to check correlation on. This would be my answer. Dr. Rabia? We don't do any options. You have to just select the variables you want to check the correlation from. And one option would be just see the lower triangle, or you will be getting confused because it's going to give you some more results. Any questions how you can perform correlation now? Does anyone have any question how you can perform a correlation analysis in SPSS? There are further techniques for sure. So basically bivariate correlation will be used. Yes. So if we go to analyze and see the correlation, other techniques, these are some other partial with this. If you want to do this, you can explore this from your end. If you're finding it confusing, you can just explore this help menu, which will take you to a page like this. I mean the main purpose, why do we split file? I mean the main purpose for doing so, I'm a little confused. Okay, so ma'am, it is nothing but as per the case studies, we are just splitting our files. As you can see that this data set shares of from a car manufacturing company. They sell cars as well and truck as well. So we have just separated our data set into vehicle type. As in you can see in the variable view, if we come to type, we have two types of cars. One is automobiles and trucks. So truck cannot be concluded into automobiles. So we have just splitted the file into these two categories and then perform the correlation. That's it. I guess your confusion is clear. And I hope my voice is audible. Perfect. So are we good to go for a lunch break now? Anyone have any question to ask? I'll wait for more minutes. Then we can down. I guess some internet issue. Am I audible? Hello, hello. All right. If I don't see any questions, Smita ma'am, you can just tell if we can go for a break or we can wait for more 5 minutes so we can join the session back by 2:30 if possible. So I've done with the. So we have completed the session 2 almost. Now we have a last session remaining wherein which we're gonna do some advanced analysis. Example, linear regression, factor analysis, what it is used for, MANOVA, GLM. So we have left with certain more 6 analysis, which are some advanced analysis, how you can perform in SPSS and things you have to do for that. We are just left with this last session. Basically, we are half an hour late. No worries, we can extend the session. So I guess there is no question right now. So we can go for a lunch break. Your permission is required if possible. Hello?
Hello, sir.
Where are
After
you?
lunch break, at what time we should meet again?
2:30, sir. I request everyone to get back by 2:30 after the lunch so we can resume the session.
So half an hour is the lunch break.
Yes, sir.
Okay, okay, okay.
Very informative and practically possible. Thank you so much, sir. I hope I was able to give you a lot. So to be honest, each and every faculty members, it's not possible to learn SPSS in one day, but I'm trying my best to give you all knowledge I have. Okay, it's gonna take months for you to get hang on SPSS, and but once you do, you will be a champion. Trust me.
Thank you, sir.
Thank you. So,
Thank you.
all, you're welcome. So we are going for a lunch now and we will see you at exact 2:30. I want everyone to be present so we can go ahead. Thank you. Thank you so much.
ये आएंगे
ये वो मीटिंग चालू है ना वर्कशॉप में।
ये यहाँ पे ना मैम सारे बड़े बड़े ऑटोमोबाइल्स के शोरूम आ चुके हैं, यहाँ पे नया डेवलपमेंट चल रहा है एंड यहाँ पे जितने भी बड़े बड़े नए रेस्टोरेंट्स है वहाँ पे सब आ चुके हैं। तो ऑलरेडी ये एक्चुअली ना मैम द कॉस्टिंग ऑफ दिस ऑल ना इस कम्स अंडर ग्राम पंचायत, इट इज नॉट मोर देन 3,000 रुपीज पर स्क्वायर फीट। हैप्पीनेस महिंद्रा हैप्पीनेस सेलिंग फॉर 47 लाख रुपीज।
ओके
महिंद्रा अब उन्होंने प्राइस कम करके कुछ 37 पे आए, लेकिन उतना है ही नहीं, तो सोचो मार्जिन कितना है। इट इज नॉट कम अंडर म्युनिसिपल कॉर्पोरेशन।
हेलो, हाँ सिर्फ मैडम।
My connectivity is also.
Yes.
You tell me that three quotation I gave us the 3 letters. उसका टाइम दिया मैंने जेरोक्स कॉपी लिया और रख दिया मेरे पास।
तो आपके पास है ना नाउ sealed quotations you have. Plus he has also given you that acknowledgement letter that he has received these sealed quotations. Okay, so what I'll do is I'll come and meet you and I'll get them opened from Sheikh. Okay, so that work order can be issued. And आपके जो CBS के room का है ना, that letter who is coming collecting, or I'll get it with you, with me.
It's already left. He started walking towards your room.
Okay, ठीक है. So I'll give it.
Hello.
ठीक है.
Yeah.
Hello, I hope everyone is back
अभी
after the
WRI
lunch.
से मेरे पास एक person आया था. They are saying कि should we keep your room or not because it is.
Okay, so can we just start with the rest of the other meeting? Just give me a confirmation that everyone is back so I can get back and start. All right, so I hope everyone is back. Let's start with the remaining analysis which we need to perform. I hope my voice is audible as well. All right.
Yes, sir, we can start.
All right, ma'am. Thank you so much for the confirmation. So, ma'am, I'm just gonna share my screen. Just let me know in the chat box or unmute yourself and tell me if my screen is visible.
Yes, sir. Yes, sir. This is.
Perfect. So let's start with the last session we have. So in this, we're going to perform some advanced analysis like linear regression, factor analysis. So in this, we won't be focusing on the detailed statistics because it takes a lot of time for you to let me know that what these detailed statistics are. So we're going to overall look at how we can perform all of this analysis in SPSS. All right. So let's get back to our case study. So the first case study we're going to look at is for the linear regression. Okay. So on your screen, as you can see, this is a small description about linear regression as it estimates the coefficients and so on, assuming the linear equation involving one or more dependent variables. So the question we're going to solve over here is again using linear regression to model vehicle sales. Again, we're going to use the same data set we use for correlation. Over here, we have a question that an automotive industry group keeps track of the sale for a variety of personal motor vehicles. So in an effort to be able to identify over and underperforming models, we want to establish a relationship between vehicle sales and vehicle characteristics. So again, we're going to use the same data set. Okay, just car sales. Let's go ahead and perform these steps and see how we can run a linear regression in SPSS. I still see people are joining. Okay. So the steps for a linear regression is this. It's on your screen. To run a linear regression, we first need to go to analyze, regression and linear. Let me show you where you can find this. You go to analyze over here, analyze menu, regression. Under regression, you can see all of the types of regression, advanced regression which you can perform. For this, we're going to go with the linear regression. We select this, we get this dialog box over here. So in this, first we need to select the dependent variables. So as per the case study, you can see we're going to select log transform sale as in vehicle dependent variable. Okay. And the rest, okay, this is a small notification about how you can sort the file in order, and rest from vehicle type through fuel efficiency, we're going to select as in our independent variable. Okay, so let's go ahead and do that. We're going to select log transformed as in a dependent variable. We're just using sales thousands log transformed into this. We're just using a log transform value. Then from the vehicle type, we want to see what are the individual dependent factors which can contribute more to our sales. So we have selected from vehicle type to fuel efficiency. We drag and drop and put it in our independent variable list. Then as per the case study, it requests us to select statistics, then go to part partial correlation and collineated diagnostic box as well. So this again goes per as per your need. You can get, I'll show you once. This is a simple linear regression, just selecting the variables we want and we can run. We can get the variables entered summary and so on. And if we want to go as per the case study, we have to just recall the dialog box, click statistics. part and partial, collinearity diagnostic box, and continue. We can also get plots as per our need. We have to just specify the values we require for that. We can also use options. Over here also we have an option. We can exclude missing values or include missing values or replace it with some mean. As I told you earlier, SPSS provides you multiple options for you to handle missing values in your data set. This is also one way to do that. In every analysis or certain analysis, you will get this option when you can handle missing values. All right. And just hit OK. So again, we're going to get the same results. Okay, so this is how simple it is to run a linear regression in SPSS. Now again, it comes your prime duty, how you can interpret to these results. We won't get into much detail, but I'll give you an overview about this. First, you get a model summary, which gives you an R square, which is a good R square, about 0.69, then R square, an adjusted R square, and so on. All right, then you get an ANOVA table and coefficients and so on. Again, I'll repeat, it's your prime duty. You have to interpret what exactly you're looking for. For this case study, we were just looking at how you can run a linear regression, and it is very simple. You go to analyze, regression, and linear regression. All right, so we have performed all these steps and seen how you can run a linear regression. And about the interpretation of output, you can see that we have got an ANOVA table which reports a significant F statistics is better than guessing the mean. Then we get a model summary over here. Then we get the coefficients table. Request to please read it once, so you'll get an idea. As the model summary, it also suggests that it's doing good job in modeling sales. Nearly half of the variation in the sales is explained by the model. Over here you can see the model summary and significance level you get with the ANOVA test and so on. If you want to know what exactly this measure means, that sum of square degree of freedom is nothing but n-1. There is a statistics related behind this. Okay. So as we selected part and partial correlation, we have got the correlation diagnostic box as well, wherein if we go ahead and interpret it, first we're going to interpret the coefficient table. What it suggests us that it model fits looks positive. The first section of the coefficient table shows that there are too many predictors in the model. There are several non-significant coefficients indicating these variables do not contributing to the model. It's interpreted through this. Okay, the significance level. Then we have a second half table. What it suggests, it has been written over here, that the table shows that there might be a problem with the multicollinearity. As you get into statistics, you see the tolerance. Tolerance is basically used for the percentage of the variance in the given predictor that cannot be explained by other predictors. Thus, some tolerance show that 70 to 90% of the variance in a given predictor, it suggests as this. Now, if you look at this collinearity diagnostic box, this VIF, which is known as invariance inflation factor, which is basically used while determining the collinearity in statistics. I won't get into detail, but an overall view. VIF and tolerance is basically used to check the collinearity as in multicollinearity in your predictors. That's what it says, that when the tolerance is close to 0, there is high multicollinearity and the standard error of the regression coefficients will be inflated. Or as in a VIF, or variance inflation factor, which is greater than 2, is usually considered problematic. And the smallest VIF in the table is 3.19. As you can see over here, that a VIF usually, as per the statistics, if it is greater than 2, it is considered as in multicollinearity problem in your model. So as per the looking at this VIF, we can say that there is a multicollinearity problem in our variables, as in our variables are correlated among themselves. That could be a small interpretation through this table as well. That's what it is written in this paragraph. Then the collinearity diagnostic box, it also confirms that there are some serious problems with multicollinearity, wherein if we want to run the linear regression model again, we have to make sure we remove the correlated variables and again run the linear regression. That's what it suggests. I hope now Everyone can run a linear regression in SPSS. It's quite simple. You get certain, these all measurements, you get the variables entered. This is the method. Yes. And one more thing, if you are aware about different types of linear regression methods, you can come here, or we'll just recall the dialog box. Okay. Over here, you can see the method. If you are familiar with core statistics, I request you to explore these all methods, as you'll be getting different values if you try and use different methods. Over here, we have used the enter method. That's why you can see in the model summary, you are getting the method as well. All right. So this is how easy for you to run a linear regression in SPSS. Now, in case if anyone has any question, you can please ask, or we can go with the other analysis, which is known as in factor analysis. Any question? I see one question. Missed a little. Could you please repeat the procedure for linear regression? Sure, Dr. Abhyam. It's very simple. You have to just make sure your data is selected, your file is open. You go to analyze. You go to regression. The regression is a point wherein you can file all the types of regression, small, simple, or advanced linear regression. For this, we're going to use linear regression just. We select the variables which we want to. As per this case study, log transform will be a dependent one, and through vehicle type, through fuel efficiency will be a independent variables. We select the variables, statistics, as per our need, we can select as many if we want, hit continue and hit OK. That's how easy it is to run a linear regression. Right? I hope it is clear now. All right, perfect. Then we go ahead and see the other analysis, which is known as in factor analysis. So one important thing about factor analysis, as you know, that factor analysis is primarily used for data reduction and structure reduction. Example, if you have 1,000 rows or 1,000 columns, it is too much for your analysis. So with the help of factor analysis, you can determine which columns or which variables are contributing more to your model, and you can use only those variables in your analysis. As you can see in this note, it is clearly written that the purpose of data reduction is to remove redundant or highly correlated variables from the data file, perhaps replacing the entire data with a small number of uncorrelated variables. The observations can be correlated, and so on. So you can also say that the purpose of structured reduction is to examine the underlying or latent relationship between the variables. Or with every factor analysis, you can also ask yourself, like with any extraction method, the two questions that a good solution will try to answer is how many components or factors are needed to represent the variables, or what do this component represents. This would be the main question you can ask yourself before doing or getting into the factor analysis, which is the prime question you can say. So let's go ahead and use factor analysis for data reduction. Again, we're going to use the same data set, which is known as in car sales. So over here, as in the problem statement says that an industry analyst would like to predict automobile sales from a set of predictors. However, there are many predictors which are correlated, which we saw in this output by looking at the VIF, the variance inflation factor. It is about 2 for everyone. So there is a multicollinearity. So with the help of factor analysis, we're going to remove the multicollinearity thing. So let's go back to our case study. So to run the case study, we're going to go to analyze, dimension reduction and factor. This is where the files, where you can find the factor analysis. All right, we go to analyze. Dimension reduction is where you can find the factor analysis. Go to factor and we select our variables. So as per the case study, same we're going to select vehicle type through fuel efficiency as a analyze variable. Let's go ahead and do that. From vehicle type, fuel efficiency will be the variable we want to select on that. Now, as per the case study, do suggest us certain more options. When it select us to says us to go to extraction and select scree plot, which is a slope kind of a plot. I'll show you that as well. Then in the click rotation, then it suggests us to go to factor analysis dialog box. Let's go ahead and perform the steps in the SPSS. We go to extraction. We select scree plots. Okay. We hit continue. Then what does this our other step says that we have to select rotation and go to select VariMax method. We go to rotation, select the method we want to. As per your need, you can explore these all methods. It's gonna give you some different measures. We hit continue. Then the case study also suggests us to save these scores, okay, on factor analysis dialog box and save the variables displays of factors as coefficient matrix. How do you do that? We go back to others, we go to scores, we're gonna save as in variables, we're gonna display factor score coefficient matrix as well. That's what our case study says. Hit continue and okay. Hit continue and okay. Our factor analysis has been done. When you do factor analysis, you get this all type of measurements as an initial extraction, then the total variance explained. So as you overall look at this table, this total variance explained, you can see that after doing factor analysis, the factor analysis says that only our three variables can easily explain all of the variance. Okay. That's what our scree plot also suggests, that rather than using all of the variables, only 3 or 4 variables can explain all of the variation in our independent variables. So it's good to select only 4 variables. That's what this scree plot suggests us. If I get back to you to the interpretation part of this factor analysis, you can read it this by your end, that the communities indicates the amount of variance in each variable that is accounted for. Then initial communities are estimated of the variance in each account for by the components of factors. This is always equal to 1 or 1.0 for correlation analysis. Then we have a small note on total variance explained, as in the explained by the initial solution. The extracted components, rotated components as displayed. The first section of the table shows the initial eigenvalues. This was all about the first half. Then the second half, as in I told you, the scree plots, which helps you to determine the optimal number of components you can use in your analysis. As in the eigenvalues of each component in the initial solution is plotted. Generally, you want to extract the components on the steep slope, which is this. Wherever you see a scree plot, specifically wherever you see where this curve is getting straight, you can conclude that almost all the variation can be explained by 4 variables itself and the others are contributing this much. That's how you can conclude through a scree plot or a total variance explained. You can see over here as well. So that's how you can interpret it as per your need. Okay, I see there is a question. Let me just address it. So these conclusions are automatically given by SPSS or we have to derive it on our own? Very nice question, sir, Vizvi ma'am. So ma'am, yes, you have to derive this conclusion from your own, because SPSS doesn't know which question or what research you are trying to solve, what question you are exactly trying to solve. So this interpretation has to be done by yourself, and it is not that much tough. If you are aware about little advanced statistics, as in the factor analysis or the estimation sums, if you know about this all terminologies and what they are used for, you can easily interpret it through your output as per your need. Okay, so that would be my suggestion. As in, you can see that they have gathered the 3 component scores in which they say that yes, we can use 3 components for your analysis, which will be better for rather than using 10 independent variables. Our factor analysis PCA same. Yes, how will we come to know about which component is affecting? Name is not mentioned in the interpretation table. That's what, again, sir, it depends upon totally you what you're trying to interpret. This you can consider. I had a really nice meeting in Gujarat, wherein the director had came into and asked people to do not focus on the statistics. You just focus on SPSS, how to use it. You can consider this software as in a calculator. It's just gonna give you what you're gonna ask you for. So it's your prime duty again to interpret what you exactly need. Okay. So my suggestion would be you just get into statistics and see how you can interpret it as per your need, because your case will be totally different. This is just a case study which has been designed by IBM for people to know how you can use it. Okay, I'm going to give you certain examples in the help menu as well in the end, wherein you can try to learn more about this. This interpretation has been done, taken out by the case study itself, which has been given by IBM. I'll let you know in the end where you can find all of the analysis case study, each and every analysis which you can do in SPSS. Example, all of this analysis, okay? Whatever comes in this as well, all of this, each and everything has a case study, dedicated case study, which is gonna take you almost a year to learn through this. So you can say this interpretation is a smaller, as in a trimmed interpretation for y'all this team has made at SPSS. Okay. Nothing will be mentioned in the interpretation table. It's your prime duty. You have to interpret what you are exactly looking for. All right. So I hope now everyone can run an factor analysis. This is just more about the component score, what it means. We can create a scatter plot as well. Let me just help you to see what the scatter plot matrix of component scores. So to produce, we go to graph, chart builder. Now if you see, we do have saved some component scores as after our studies. So whatever components the factor analysis suggests us, it has automatically saved over here. Okay, in the right end. So we're gonna run a scatter plot now and see what, just reset it and refer you to the case study. So the case study suggests us to select scatter plot, the chart type, and drag and drop scatter matrix. Select reg r factor score 1 for analysis 1 through reg r factor score 3 for analysis 1 as variables. Okay. We go to gallery, select scatter plot. Now we have new component scores. This and this. Okay, so we have to select scatter plot matrix. Okay, we have to select this matrix. We select it, drag and drop over here. Select the variables, drag and drop over here and put it. Why it's not taking? Okay, I guess there is some issue with this, so we won't continue ahead to running a scatter matrix. There is some issue, I'm not sure. I'll get back to you regarding this. I guess there is some issue. Okay. So this is how you can run a principal component. Yes, principal component analysis and factor analysis is same. Factor analysis is further classified into data reduction and structure reduction. So in data reduction, you try to reduce the data as per your need, because when you have a lot of amount of variables as in observation into a smaller observation, and structure reduction is basically used when you have n numbers of columns, example 1000 columns, and you want to see which all columns contribute more to your analysis. So you can use factor analysis. They compute the variation and put it into a component as well. So now next we are done with factor analysis. Let's go to MANOVA. How you can perform MANOVA test in as in a multivariate analysis of variance in SPSS. So for this case study, again we have some notations that it allows you to model the value of multiple dependent scale variables based on your relationship. Sure. So this answer was for Shurbi ma'am that she wanted recording. I will do share the recording link. So the model for this purpose, we're going to test hypothesis concerning parameter estimates the GLM multivariate procedure assumes. So again, we're going to have some assumptions for this analysis. So the assumptions are overlisted below over here. Request you to please go through it. As in the beginning, I told you that every analysis has some assumptions. You first make sure you validate your assumption, then proceed ahead with your analysis, whatever you are willing to do in SPSS. So this is the assumption. I'll wait for 1 minute. I hope everyone has read through this. Now let's go ahead and perform the multivariate analysis, which is known as a MANOVA. This is the problem statement. Request you to please read this by your end. So over here, we are not trying to do anything. We are just as a part of our initial treatment of myocardial infarction, which is an heart attack. A thrombolytic or a clot dissolving drug is sometime administered to help clear the patient's arteries before surgery. So three of the available drugs are in the medical field available: alteplase, reteplase, and streptokinase. Wherein they say that alteplase, reteplase are newer drugs and more expensive drugs. And a regional healthcare system wants to determine whether they are cost effective through to adopt in some place of streptokinase. As in these two drugs are cost effective as an expensive drug. They are trying to see if these two drugs can be used in place of this drug, which is streptokinase. That's what this case study is all about. Okay. So one of the benefits of thrombolytic drug is that surgery generally proceeds very smoothly, resulting in shorter recovery period if the newer drug are effective. The patients given those drugs should have shorter length of stay in the hospital. We have all the data collected in this sample file, which is known as in Petlos sample. Let's go ahead and open this file. Okay, so how you open a data set in SPSS? We go to File, Open Data, navigate through the path wherein we have saved the file, or either we search it over here. We're gonna use Petlos sample for this analysis. So this is the data. Just close all other outputs. Okay, so this is the dataset Petlos sample wherein we have some variable known as an age, gender, whether the patient has a diabetes or no, any BP problem, does the patient smoke, cholesterol activity, and so on. All right, so this has been recorded observation. If you want to see what value labels they have put it, you can easily use this shortcut to see yes and no. It has been recoded through the variable view. Over here you can see that. Now let's go ahead and see how you can perform a MANOVA in SPSS. There are certain steps you need to follow for that as well. These are all the steps. So while performing a MANOVA test, it is a little complex and an advanced analysis. So you have to make sure you are selecting proper variables to get an appropriate results. So over here, let's go ahead and perform it. Where do we find MANOVA in SPSS? We go to Analyze, Generalize Linear Models, and Multivariate. Multivariate is a dialog box which is known as in MANOVA test. Okay, general linear model, multivariate. So over here we're gonna select length of stay and treatment cost as in a dependent variable. Okay. So length of stay and treatment cost is gonna be a dependent variable. Then we're gonna select clot dissolving drug and surgical treatment as a fixed factor, as in our independent variable, clot dissolving drug and surgical treatment. Where is clot dissolving drug and surgical treatment? This is gonna be our fixed factors, our independent factors. Okay, so let's see if we are missing any steps. Okay, then the case study suggests us we need to go through contrast, select clot dissolved none as in contrast to change. These are all advanced analysis techniques. You need to be familiar with this all detailed statistics. These are the core statistics which SPSS follows. Request you to please read through it or get some information before you use this kind of advanced analysis. In case if you are facing any issues, you can explore this help menu as well. This is gonna give you a documentation page wherein it has been mentioned in a very detailed what this analysis can be used for. Okay, these are all detailed description about GLM multivariate, which is a MANOVA test. Okay, so whenever you are finding any difficulties in understanding how you can perform the test or for what purpose it can be used, I request you to explore this help menu. All right. So again, we go back to the case studies. In the change contrast group, we select simple as in contrast type, which is over here. They are suggesting us to change the contrast type as in simple for this case study. So this case study has been designed in a very detailed manner once again by the IBM, all right? Your case would be totally different. Then in the first reference group, we have to select first as in reference category. Okay, we have selected first as in reference category. Click change, then continue. All right, we've been done. Okay, and okay. So your multivariate test is done. Again, I'm going to tell you that you get this all output when you run a multivariate or MANOVA test. You get between subject factors, between the drugs, you get the surgical treatment, their number of observation we have. Then we get multivariate test dialog box in which we get value, F statistics, the hypothesis degree of freedom, the error degree of freedom, the significance level. We get the test between subject fields with some measurement levels, again some detailed statistics. Then the contrast result, the K matrix, which is on an advanced level. You need to have some masters in degree for this to understand. All right, so that's how easy it is for you to run a multinomial. Again, there are certain steps. The case study suggests us to option dialog box, estimate the effect size. SSCP matrix is the sum of square cross products. Then once again, we did one mistake over here. We have run the MANOVA test without clicking. Just a minute. Yes. As I told you in the beginning, as we have done ANOVA test and it does test the homogeneity of variance. Same goes for MANOVA test as well. To run a MANOVA test, you need to make sure you remember this dialog box option and you do select the homogeneity of test. If you don't select this, MANOVA test won't be performed and won't be seen in your output. Okay. So as per the case study, if we go to, we have forgot this step. As in this dialog box, we have to select the estimate of effect size, SSCP, homogeneity, spread versus level plots, and so on. Spread versus level estimates of effect size, SSCP metrics. So these are also measurement levels which you require to validate your assumptions or results after performing a MANOVA test. So these are all the measurements level. As per your case study, you have to select it. Make sure you do select this homogeneity of test, which is very important. This only means that you are performing a MANOVA test, and same goes for ANOVA, homogeneity of variance test. You select select this, then only the maneuver test will be performed and hit OK. So this is the exact output you will be getting after you perform a maneuver test in SPSS. Okay, wherein in the end you will be getting the test result dialog box as well. Now, if you go ahead and try to interpret it through this, it's going to take you a lot of time for the interpretation, as there are a lot of things to be considered, a lot of statistics, a detailed core statistics you need to work on to interpret it through a maneuver test. And SPSS is a very statistical, powerful statistical software. That's why you get all of this statistics in one go, which saves a lot of time. Okay. So that's the reason we are getting this spread versus level plots of the treatment cost is because we have selected over here in this plot dialog box. No, in the contrast itself. Model, no. You can also save some unstandardized or standardized values as per your need if you want to. I request everyone to explore this all dialog box so you'll have a brief idea about what all things you can get in just one click. Okay. So now I guess everyone can run a maneuver test in SPSS and interpret the result as per their needs. I'll do share this case study so you can take your time out and run some analysis on your own and get hands-on practice as well. Okay. So that's how easy it is to run an maneuver test in SPSS. Where do you find that? We go to analyze, then we go to general linear model, and multivariate is the place where you can find maneuver test. This is the maneuver analysis. Okay. And again, there is a lot of interpretation for this. You can see there are 3 pages of interpretation done in a detailed manner. Actually, this is also a trimmed manner. In a detailed manner, it's going to take a lot of actually 5 slides, more than 5 slides. That's what the interpretation of maneuver test will look like. Okay. Any question how you can run maneuver tests in SPSS? I guess it's very simple and easy. You have to just figure out what variables you need to select for and what measurements level you require to validate certain assumptions. All right, let's go ahead and see how you can perform a more advanced analysis, which is known as a generalized linear mixed model, which is a GLM procedure. Again, this model is extended to a linear model so that the target is linearly related to the factors and covariates via a specified link function. There are a wide variety of models from simple linear regression to complex multi-level models as well. So how you can run a GLM in SPSS? Let me show you that as well. The problem statement for GLM, we have profiling cable customers. So as an executive at a cable service provider of a television, phone and internet service wants to know more about potential customers, they conduct a survey of 2,000 people, okay, in their service region and ask whether they don't have the service or have subscribed to their service or any other providers have their service with the company for each 3 services and so on. So this is all about the DS surveys they have conducted, and the survey data is concluded stored under this file. Let's go ahead and open that. We go to file, open, search the data set we require, cable survey. Once again, .sav is the extension for sample files in SPSS. Okay, we hit OK, open. So this is how the output will look like. Let me just close the. Okay. So this is the data set we're going to work for GLM, generalized linear mixed model. Here we are profiling customers of a cable provider. So this is how the data will look like. If you want to see what are the value labels we have performed, you can just click it over here or go to variable view and see the variables what they have defined it for. Okay. So let's get back to the case study. So again for this, as I told you that this is a very advanced analysis, GLMM, generalized linear mixed model. It's going to take a lot of efforts for us to create some models. There are around 20 steps we need to follow. So I'm going to follow one by one slowly. Do not get hyper or do not get stressed out that you won't be able to perform all these steps. There is a place I will let you know where you can find a reference guide for yourself when you want to do this type of advanced analysis. Okay. So where do we find the generalized linear mixed model? We go to analyze, mixed model and generalized. We go to analyze, generalized linear models and generalized linear model. Yes. Again, we go to analyzed, mixed model and generalized linear model. This is where you can find GLM, generalized linear mixed model, which is an extended version of linear regression models. So the dialog box will look like this. You have to do a lot of tuning, a lot of variables you have to select. Let's perform that slow by slow. So on the data structure task tab, they want us to select customer ID as a subject field. Let's do that. So we have a customer ID. We are going to select customer ID as in a subject field. Okay. We have performed the step number 1. This is done. Then the case study request us to do click fields and effects, which is over here. Fields and effects. Then over here we have to make sure that on the target settings confirm that service usage is selected as a target variable and the multinomial logistic regression is selected as a target distribution group. Over here we have to make sure that service usage is selected as in a target variable and multinomial logistic regression in the target distribution group. Okay, you have to make sure this is selected, or you can perform the other analysis as well. This is where you can find binary logistic regression, binary probit analysis, and so on. So for this case study, we're going to go with multinomial logistic regression. We are done with these steps. Then it again says us to go to fixed effects. On the fixed effects settings, select level of education, income category in thousands, number of people in household, and service type, and drag to the main drop zone and create them as in main effects. So we have to go to fixed effects again over here. We have to select the variables, level of education, income category, and what it was, level of education, income category, number of people in household, and service type. Number of people in household type and service type. We select this. Just a minute. Okay. And we drag it, drop, and create a main effect through this independent variable. Okay. So what we are trying to do over here, we have selected our target variable, which was a service usage, and we are trying to see if these 4 variables impact our service usage or not. Okay. That's what we are trying to do over here. We have created them as in main effects. Again, these are all the random steps. I'm just gonna do in a fast forward manner. Please excuse me for that. Random effects. We go to just a minute. Go to random effects. We select add block, in which we have to mention certain things, include intercept. We have to make sure we check this box. Customer ID from the subject combination drop down menu. Customer ID. Okay. Okay. All right. This is the only step we required. and we run it. So in the end over here, you can see the program is being run in the background. It's gonna take few seconds. Again, I'm not just going into core because it's gonna take a lot of time, and in one day, I'm just trying my best for you to understand that these are things you can do in a simple manner. So you get a case processing summary with valid, excluded percent. If we have opted in for include or exclude missing values, then we get a model summary. These are all the statistics. Then we do get the data structure table. We get the classification as in the model suggests us we are 85% we are estimating correct estimates. You can see this as an accuracy of our model as well. You can see our model is doing 85% accurately, which is a nice accuracy in terms of this. Then the other levels, other measurement levels you get in general linear mixed model, you get fixed effects. Then you get fixed effects in a diagram as well, which the stronger, the thicker the line is, it's contributing hard to the model, as in more to the model. Service type is contributing more. Then we have income category, then education category and residential address, which is almost a little light squid. Then we get fixed coefficient case in this. We do get fixed coefficients diagrams as well. As in you can see, it mentions that blue is the negative impact and the black one is the positive impact to our model. This is also one way you can interpret it. You get random effect, covariances, and so on. You can say that these are detailed and a very advanced core statistics, wherein if you want to perform this analysis, you need to be aware about this measurements level. Okay, so that's how you run a general linear mixed model. You need to do some tuning as well. You go to analyze, mixed model, and generalize linear models. Over here again, you have to select the variables you need, and as per your analysis, you can proceed ahead. Okay, so this is how you can perform a generalized linear mixed model. Again, with the interpretation part, again, the case study suggests us we can also build some more models to compare between which models are doing good or going bad. This is what the case study suggests. I'm going to share this case study with you all so you can do this from your end and take a feel. How does it feel to do certain analysis in SPSS? Okay. And again, this is the interpretation of the output we have got. It is around 5 pages. I don't want to go into that core. You get accuracy chart from model summary, you get accuracy chart from model summary for generalized logic models, and so on. This is small descriptive about what this result says, and so on. Okay. And this is a small summary. I will do share this PPT with you so everyone can get hands-on practice. Then again, for a binary logistic regression, how you can perform it, let's go ahead and do that. So in binary logistic regression, it is most useful when you want to model the event of probability for a categorical response, example 1, 0, 0, 1, 0, 1, 2, 3, and so on. So these are the use cases wherein you can use binary logistic regression in your analysis. You can use a catalog company wants to increase the proportion, or a doctor wants to accurately diagnose a possible cancerous tumor or not with certain factors. A loan officer wants to know whether the next customer is likely to default or no. So in these use cases, binary logistic regression can work really better. All right. So for this case study, we will be looking at the credit risk, as in how helpful it will be for us to measure which customer is likely to be, get loan on default and so on. So as over here, you can see if you are a loan officer at a bank, they want you to be able to identify the characteristics that are indicative of people who are likely to default on loans and use those characteristics to identify good and bad credit risk. Okay, suppose we have 850 past and prospective customers contained in a data set known as in bankloan.sav. So let's go ahead and do that. We go to file, open data. We search the data set bankloan.sav. We open it. Let me just close the other output. Okay, so this is the bank loan. You can ignore these three values. So these are the variables. We have age, education, employment, address, years at current address, how many years the person has, then their income level, their debt level, then so on. Now let's go back to our case study and perform a binary linear regression. Sorry, binary logistic regression. The first. So what this case, this data suggests says that we have 700 cases are customers who are previously given loans. So we're going to use a random sample of this 700 customers to create a logistic regression model, setting the remaining customer aside to validate the analysis. As you know that in machine learning or in any model building, we use only 80% of data and we keep 20% of data to check the accuracy of your model. That's what we are trying to do over here. We're going to use 150 customers to check the credit risk, as in to check our model how good and bad it is performing. So for this, first we need to perform the data for analysis. So for this, we're gonna set some random seeds, which it's gonna help us to select random variables. And how do we do that? We go to transform, and let me show you how you do that. To select a random seed, we go to transform and select this random number generator. We get this dialog box. So as per the case study, you can select the random number generator as per your need. Okay, no need to follow the case study. It depends on your case, and each case and scenario has a different point of view about that. So we have to set a starting random point. This is the fixed value we can give. This is a totally random value. Okay, I'm gonna select that fixed value. This can be done as per your need. This is totally random. So now to create the selection variable for the validation from the menu, we are going to create a new variable over here. Okay. And how do you create a new variable? You go to transform, select compute variables. You get this dialog box. Over here, these are the functions which SPSS offers. It's a lot of function. Everyone has a lot of other functions in a detailed manner, which again consists of core statistics, totally advanced statistics. So as per your need, request you to explore this as well. You can use a lot of functions. In your case, it can be a different as well. So over here, what we're going to do, we're going to type validate in the title. We're going to create a new variable, which we're going to call it as in validate. This is where we name it. We can type and label it as well. Does anyone have any question? I see. All right. Okay. So we're going to provide what do you say, an expression or condition over here where what we want to do. So we're going to type RV Bernoulli, which is a function as well, which says that we want 70% of our data to be separated randomly, which we're going to test our model on. Okay. You can see this sets the value to validate to be randomly generated Bernoulli variates with probability of parameter of 0.7. It means 70% of our data we're going to use in our model building. Again, a small note, we only intend to use validate with cases that would be used to create the model, that is the previous customer. However, there are 150 cases corresponding to potential customers in the data file. We give the condition over here. You can also provide an if condition, a certain other condition in this as well, as per our need. This is nothing but providing a simple condition. We're not going to do anything about this. On this step, then to perform the computation only for previous customers, click if. We're going to give us if condition as well, in which we're going to use only values which are missing is the 0. Okay, I'm going to show you how you do this. We select include if case studies and type this condition over here. If condition over here. Okay, we have provided the conditional experience over here. This ensures that validate is only computed for cases with non-missing values for default, that is, and the customers who have previously received loan. You click continue, okay. Click continue, okay. Now in the background, almost 70% of our data has been acquired for the model selection. Okay. Now let's go back to the case study. As in you can see that approximately 70% of the customers previously given loans will have a validated value of 1. These customers will be used to create the model. Remaining customers who are previously given loans will be used to validate the model. Now let's go ahead and run the analysis. We go to analyze, regression, and binary logistic regression is where you can find the binary logistic regression. Again, we go to analyze, regression, and binary logistic regression. This is the dialog box you will be getting. Over here we have to select now previously defaulted as a dependent variable. Where is our previously defaulted people as an independent variable? Age in years through other depth in 1000 as in a covariates, which will be our independent variables. Age in depth, sorry, age in years through other depth. We're gonna select it as in covariates. Okay. Now the case study suggests us we have to select forward LR method. So again, binary logistic regression can be used with multiple methods. These are all methods in which you can use in binary logistic regression. Okay. So for this case study, we're going to use forward LR. That's what our case study suggests as forward LR. Now to select validate as a selection variable and click rule. Okay. We're going to select the variables which we created in a validate variable. Drag and drop here and click on rule. Now we're going to define the rule as per our need, as per the case study. We select set rule dialog box. We type 1 as the value for selection variable, as in people who are not defaulted on loans, equals to 1. We hit continue. We have done this step as well. Now click categorical in logistic regression dialog box, which is this dialog box. We click here and we have to select the categorical covariates. Okay, so we have more 8 steps to follow. So let's select level of education as a categorical covariate level. This is the only categorical variable we have. We select it over here. Then we click continue, click save in the logistic regression dialog box. We hit continue. We click save on logistic regression dialog box. Again, if we want to save certain measurement levels, as in the probabilities, the group membership, or the unstandardized, the residual errors, that's what it is considered in statistics format. We can select it over here through this dialog box, save. Now, as per the case study, suggest us to select probabilities in the predicted value groups. We select probabilities in the predicted value groups, as in we'll be checking that what is the probability of a person to default on a loan or no. Then we select cooks in the influence group. We select cooks in the influence group and student eyes as in a residual groups. Student eyes and a residual groups. Okay. Hit continue, click options in logistic regression box. Then again the case study suggests us to explore this option menu as well, in which let's see suggest us to select classification plot and Hausmeyer-Lemaitre goodness of fit. Again, classification and Hausmeyer-Lemaitre goodness of fit is a detailed course statistics which is used to validate our binary logistic regression model. Again, this is a core statistics. Won't get you in this detail or you will be lost. Okay, so we hit continue and okay in the dialog box. We have completed all the steps and click OK. So again, this is our binary logistic regression has been done. We have created a model as well. Now we get so many of output. This is known as a leaf plot. Okay, so you first get the case summary processing, the number of values present, missing cases if you have any. Then you get dependent variable encoding, which we have 0 for no, 1 for yes. Categorical variables coding, and so on. Now again, it's your prime duty what you have to interpret it through this model, as in what answers you are trying to, questions you are trying to answer with this building model. Okay, you get the significance level, you guess theta value, and so on. So I hope everyone can run a binary logistic regression again. I saw some questions, let me just address it. Yes, please share the PPT. Yes, sir, we will be following. I will share it. Sure. Okay. So this is how you can run a binary logistic regression. You need a lot of hard work to do to run a binary logistic regression, as it is a very advanced analysis. This is where you find it. One second, I see a question. SPSS is free for 1 month. After that, what are the charges for SPSS and how to pay, and is the payment monthly or annual basis? Okay, so answer this question. We do provide SPSS, but on a perpetual basis. Perpetual means you can get license for a lifetime access. You have to only pay once. And if you do require on a payment of a monthly or annual basis, you need to get in touch with IBM, because IBM does this business on a, what do you say, yearly basis or a monthly basis. They do provide subscription, but they cost in some dollars. So if you want, I can get in touch with you with our sales team who can help you with this. But yes, we do provide SPSS on perpetual basis, which is a lifetime license key you'll be getting with certain modules, whatever you opt in for. Okay, so this is how you can run a binary logistic regression in SPSS. And again, there is a lot of interpretation about this. I won't get you into this detail as we have a very short period of a time, choosing the right model and so on. Then automatic data preparation, I don't think so you have opted in for, and so on. So yes, and after this, sir, can you please tell us how to remove outliers? Just a minute. How to remove outliers after you finish the topics. Yes, so there are multiple ways wherein you can handle outliers in SPSS. Okay, either you can create a scatter plot from here and see if there is, like the way I showed you for the car sales, you can just see which point lies very far from the minimum or maximum, or you can use the standard method, which is a box plot, to which you can create some box plot and see if there is any outliers or no. Or there is other ways as well, as in the I don't remember exactly. There is a formula for that as well, wherein you can Q1 minus Q2 0.73, some kind of a way. There is a way to remove outliers. So there are multiple ways, sir. I will suggest to explore each and every one and see which fits better for you. One is with the standard ways using box plot. Okay, so this is how you check if you have any outliers. I won't get into this detail. And yes, about custom tables. Now how you can create custom tables as per your need. Okay, so for that as well, we have a data set. I'm going to use employee data. See how you can customize or create customized tables as per your need. So in order to create the customized table, where you can find it, I'll just show you. You go to analyze, you see this option table. As you all have opted in for custom tables, this is where you can create custom tables as per your need. This is gonna be the dialog box is going to be shown every time you open this custom dialog box. Then you click OK, or you can define variable properties as per your need. Now this is the dialog box, the canvas wherein you can create custom tables as per your need. Example would be, if I want to create a, what do you say? Okay. If I want to create a custom table as per my need with employee category as in row and gender as in columns, this is way how you can create. Okay. And you can do right click and get summary statistics, when you can define what you want. If you want row and percent, these are all the other metrics. I request you to explore it by your end. That there is so much you cannot, I won't be able to explain you in one day or in a short period of a time. It's going to take you minimum a month to explore. This is from your end. You can get row and percentage as per your need. Click there over here, apply to all section, close. Now you'll be getting row and percentage as well. Now if you want some more statistics as in categories and totals, you select over here. You get the grand total over here as well. Click apply. Now in the end you'll be getting grand total over here, as you can see. So this is how you can create custom tables as per your need, and hit OK. Your custom tables will be created as per your need. Again, how you can create custom tables in SPSS? You go to analyze, tables and custom tables. You can either select this dialog box as per your need and define the variable properties. We're gonna reset it again. Then again, as per your need, you just select the variables you need as in a row column or as in column point as per your need again. So this is the way how you can create an custom table as per your need. You can do check, right click. These are all the options SPSS provides you. You can either make changes in this rows or this column as well. You can get the summaries as well and so on. You can edit titles if you want. You can give some test statistics. These are also a small enhancement and so on. So I just show you a small overview how you can create custom tables as per your need. You can give a default position. And in case if you're finding it difficult over here, how you can create it, again, request you to explore this help menu. It's going to take you to this documentation and give a detailed manner specification what where has to be selected and for what purpose you can use these custom tables. All right. So this was all about. Now, is there any question I can help you with, sir? Yes, last thing but not least, as I wanted to show you where you can find more case studies and learn more about SPSS is this place. Okay. So first thing first, in case if you are doing certain analysis and you are very sure about it, yes, you have seen that analysis somewhere in SPSS under some menus and you are not able to find it. I'll give you first way how to find it. You go to this magnifying glass and search whatever you want to. Simple linear regression, binary logistic regression, whatever analysis you think you have seen and you're not able to find it, you can just use this menu and search whatever you want to. It will be one way. Yes, absolutely. Practice makes us perfect. Need to explore, and self-learning is the best method. That's what, sir. So for self-learning, I'll give you one more way wherein you can explore things from your end and learn a lot and excel in your research or your analysis field. Okay. So you see this, just a second. Okay. So you see this help menu. You go to this help menu. You go to topics. It's gonna lead you to a documentation once again over here. If you are facing any issues, so you go to help menu. These are all the options. You get tutorials as well. This is the place case studies where you have to click if you want to learn more through the case studies. And once you look through the case studies, you see these four options: base, standard, professional, and premium. Under this four tab only, each and every case study is present. Linear regression models, unique meta-regression, summary statistic using descriptive, exploratory data analysis, analysis of classification using crosstabs, then summarize procedures, mean procedure, t-test in which you can find one sample, paired sample, independent. So this is the place, a hidden gem wherein you can learn more about SPSS. That's what I can say. Partial correlation, linear regression, so on. Nearest neighbor analysis, discriminant analysis, factor analysis, and so on. Hierarchical cluster. You click over here, you follow the steps. It's going to give you just a small introduction about what this does. You hit next and just follow all the steps which is mentioned in this clear case study. It's going to give you a brief demonstration about each and everything, what this can be used for in your case. Again, you can classify automobiles with a case study known as in car sales. As an example, we did linear regression and correlation on. You just keep hitting on next and follow the steps which has been mentioned. So IBM has done such a nice thing. They have made a case study for each and every analysis you can do in SPSS with a screenshot and a mentioned steps as well. So it will be very easy for you to understand SPSS from your own as in a self-learning method. Alright, so this would be the last thing I would like to let you know. So over here there are more than 100 analysis, okay sir, each and every one. So there are more than 100 analysis, ROC analysis, control charts, and so on. A lot of things, and which will be categorized under only these four menus: base, standard, premium, editions. Okay, you can see Kaplan Meier survival, Cox regression, binary logistic, multinomial logistic regression, probit analysis, and so on. Every analysis, there is a dedicated case study for that. So request you to please explore this from your end. How do we conduct non-parametric tests? Sir, if you have opted in for the modules, again there is a dedicated case studies in these. Okay, just look into that. And if still you are not trying to find out, I will request you everyone first of all to just note down my email address. In case if you have any queries regarding SPSS, you are not trying to find it out, you can drop a mail to me on this mail address, gaurav@spss.co.in. I'll try my best to help you. As in our team will help you. We have a team of statisticians. How do we conduct non-parametric test? Again, sir, non-parametric test in SPSS, I'll show you where you can find it. It has to be done by your end. You go to analyze. If you have opted in for and you have got the exact test add-on module, you will be getting this option non-parametric test, which is basically an add-on module separately. Over here, you can see all of the non-parametric tests with the legacy dialog box, wherein one sample KS is to check the normality of your data or variable, which is Kolmogorov's test. Alright, so this is where you can find non-parametric tests. I hope I tried to each and everyone's question. Lucid explanation. Thank you sir, thank you so much. Is there any question you can please do ask? I'm done by my side. I try to give you all the knowledge in one day as possible for me. Do let me know, is there anything else I can do? Please note down my email address. In case if you have any queries, you can mail it on this address, gaurav@spss.co.in. Our team will get back to you. Sure, thank you so much. Yes. And those who all really like the session and do want some more knowledge, you can please drop a feedback mail so I can prepare some good sessions for you people and help you in all manner I can. Okay, someone has requested to type in the email address. Please do provide a feedback as well for me, which will be helpful a lot. Sure, sure. I'll share the PPT and the recording with Smita ma'am as well. All right. Thank you so much, ma'am. Thank you so much. Your words mean a lot. Will it possible for us to get a certificate or an acknowledgement that we have attended SPSS? So this was a workshop attended by made by Mumbai University. That's my university as well, from which I have learned a lot of things. I'm so sorry, sir. I have no idea about it. Regarding these certificate sessions, I believe Smita ma'am would be the right person to address this. Now, Smita ma'am, if you can hear me, just to let you know, I'm done with my session. If you have anything, do let me know. I can do. Any book recommendations? Yes. As in the beginning, I told you, you can just visit this link, which will be very helpful for you to understand some statistics in core. You can validate, you can see what all assumptions it requires for certain analysis and so on. Sir, what is the amount of the SPSS for lifetime? Sir, you need to just drop me a mail on my email address with which modules you require. I'll let my team to get back to you. Because the costing is totally handled by the sales team. I can only help you with the software basis. Sure, I mentioned in the chat as well. It's gaurav@spss.co.in. I think Smita ma'am is already offline. So anyone would like to volunteer and just end the session, or do I end it from my end itself?
I'll take this opportunity, Gaurav. Thank you on behalf of University of Mumbai and ICSSR. I would like to thank you for a very informative and a knowledgeable session. Thank you, Gaurav.
You're welcome, ma'am. Thank you so much for your kind words. Really appreciate it. So let's call it a day. We had too much to download today.
Thank you, Gaurav. Great session. Thanks.
Thank you, thank you. Yes, you can provide your feedback on my email address as well. It's fine. On the gaurav@spss.co.in. Will be appreciated. Thank you, everyone. Thank you so much for giving me your
Thank
time
you.
as well.
Thank you.
Thank you,
Thanks
sir.
a lot.
God bless you.
Thank you, thank you. All right, then. Take care, everyone. Goodbye. Have a good day.
Goodbye, sir. You too have a good evening. Thank you.
You too. Bye-bye. So we'll be ending this session. I'll make sure I share the PPT and the link, recording link with Smita ma'am, so she can circulate it. Okay. All right. Then thank you, everyone. Goodbye. Take care. Have a nice day.